really, really difficult.
What did people do?
I mean, there are a number of things like you said, like the flip mirror is actually a good thing. Once you get the flip mirror sort of calibrated and the eyepiece in it parfocal with the camera, one of the biggest things is just where is it focused? Because when you're shooting planetary stuff, you're shooting at typically a very high f ratio, right? F20 or F30 or something like that.
I was doing it
So
F10, struggling in F10 already.
F10, yeah, I mean F10 is significant. Um, Better than F20, obviously, but very slight changes in focus will make a big difference in whether you can see a planet. Because they're bright relative to deep sky objects, but they're still not real bright. Um,
Yeah. I mean, the
and if
issue
it's a
is
little
not.
bit out of focus, that donut, that light that disperses in the out of focus donut can be very hard to see.
No, I made some 3D rings and I made them fairly exact. So it's not the issue of once I see it, I may be a little out of focus, but just putting it
Okay.
in the middle of the sensors. Look at the thing, it's so tiny that maybe the flip mirror is not exact. I don't know if I should get a more expensive one or something, because that really is just prevents me from having fun.
Hey,
Yeah, I mean,
Tom.
one thing that if you have the moon out, like for instance, tonight at around 1 in the morning, a little after 1 in the morning, is the last really visible Titan shadow transit. Is from like 1 to 4 or 5 in the morning tonight. Um, Fortunately, like the moon's out.
No, I was working on Albiero first because they're so easy to track. But even I struggle. I mean, anyway, go on. I'll think of something, and maybe get a better mirror that's more accurate.
Can
Maybe
you
there's some.
adjust it? Is it adjustable, your flip mirror?
I didn't notice any
Because they
adjustment.
might have an adjustment. Like if it's not exactly, 90 degrees or whatever, I guess 45 degrees, right? When it's
Yeah,
looking
yeah.
up, if it's not exactly 45, it's going to shoot it a little off axis. So they might have a
Uh,
little set screw in there to make sure
yeah,
exactly the right angle that it's transversing.
it's a good idea. Maybe I'll just put two eyepieces and go back and forth until I get it right.
I've used the moon,
Yeah.
like the moon is my friend in that situation personally. I find I'll like target it, make sure that I'm in focus, and then I'll find a small crater that's easily discernible. And then I'll get the uh I use my finder, just my little 8x finder, and I just make sure the crosshairs are like as close as I can get to that crater.
Yeah.
And then that's been enough to be able to just sort of hunt it around and find it. So even something like that, you
Yeah.
like your finder, using your finder with a crosshair eyepiece,
Yeah.
that's very accurately set.
Yeah, I mean
Hey,
the
Tom.
finder is fine because it's right in the lens, but I think having two eyepieces, you just gave me the idea. If I have two eyepieces, I don't have to worry about the camera. I put two eyepieces the same strength and go back and forth, see if I see a movement of the image. If I do, then there's an adjustment needed.
Yeah.
Anyway, Joe, you're gonna say something?
Um, I'm just wondering if maybe a reticle on the flip mirror would help. Even though you're using a flip mirror, the image is still pretty small in the field of view. And if you tried using a reticle eyepiece on there with the flip mirror, it would at least tell you if the flip mirror is um, is aligned with the camera
Yeah.
itself.
Yeah.
I think I might have one. I can look around for one and see if that might help.
Yeah, it might be.
It would at least tell you if the flip mirror is accurate or not,
Yeah. Yeah, it's a good
Um,
Yeah.
idea.
but just a thought.
Yeah, yeah. I have one, but maybe I should get two so I can flip back and forth to get it exact. And it would be so much more fun to just find the planet and Jupiter's coming up. So no, it's that season. So that's what I've been waiting for a while. Anyway, I'm done. Thank you.
Trying for the transit, are you? Tonight?
Yeah, not tonight. I've got to go down to the embassy down in DC for something. So, but I think there's another one coming up on the 17th, right?
There's
One.
one. Yeah. And then I think the last one's in October, but it's not a good time and it's not a good transit. So I think you have the one tonight, then there's one more afterwards.
Yeah, so maybe tonight too late, but maybe by the 17th, I'll get it figured out. Thanks, guys.
You're welcome. When you without the flip mirror, are you putting like an eyepiece or something in the like in place of the camera with an extension tube to use that as a centering? Because that's another technique, like especially like what Joe said with the reticle eyepiece.
Yeah,
This way, at least you know that the planet's on axis. Because you said your tracking was good.
oh yeah, once I can zoom in on the region of interest, it just sits there.
Yeah.
Okay, I have, yeah, I will play with that. I have one eyepiece reticle that I made myself, so it may not be exactly in the center, but you got me some ideas that I can work on. Thank you.
Okay. Okay.
We have a last call for any beginners questions or people who are new tonight who wanted to get their question in before we get too wild.
Question,
Wild.
Gary.
Yes.
I believe Canon cameras have a routine where they identify their own hot and cold pixels. Have you ever heard of that?
I've just heard, I haven't heard of identifying that. I've heard of them doing kind of like a dark frame subtraction
Right.
automatically. That might be what you're referring to.
Well, this specifically is you would select the manual cleaning from the menu, and what it does is it opens a shutter and flips a mirror up,
Yeah.
so you can mess up your sensor if you're fumbling. But it's said that if you engage that that manual cleaning and wait about 30 seconds, then just turn the camera off, it starts a routine that identifies hot pixels. That's what I've heard.
Yeah.
ChatGPT actually told me that.
Okay. I'm not familiar with that. I've never even used the I mean, other than trying it, I don't even do the dark frame subtraction, the auto noise reduction stuff,
right.
because I just shoot darks. I don't want to spend that time when I'm
Yeah.
out under the stars, because it's the same amount of time every exposure than it does a dark.
Right.
It's the same. So if you're doing 2-minute subs, you're kind of wasting 2 minutes every time you hit the shutter.
Yeah.
It's better to just have
Nelson,
sort of a library. What's
yeah,
that?
excuse me, I'm sorry, I didn't mean to interrupt.
No.
One caveat to doing the mechanical cleaning is that if you've taken flats and then you do a mechanical cleaning, the flats may not then be accurate. Because the dust that was there, that one of the things that the flats do is subtract dust. If you then remove the dust after you take the flat now thinks there's dust there when there really isn't. So when you apply the flat, it's not accurate. And our late head of astrophotography, Lou Barbarisas, had a problem for like 2 years. He couldn't figure out why his flats weren't working, and that was it. And I always kind of remembered that. So I'm just mentioning that if you do the mechanical cleaning, you may want to shoot new flats afterwards.
Yeah.
Okay, and I think Michael, you joined recently. Did you want to get one in for?
Yeah, just two quick questions.
Yeah, welcome.
If you may. Thank you. Yeah, I'm just joining. And I have an Orion telescope. I like it, reflector. Not top of the brand, of course, and it's old, out of date. So my first question is, do you know of a place to get the lens inside of the telescope clean? I saw a video on YouTube, and I think I could do it, but I really don't want to do it. I want someone to really to do it. I don't want to bother with it. And the other question is, I got a star in my backyard maybe about a week or two ago, and then I was trying to fine tune it to get it to fine tune it into the telescope onto the computer for my to take a picture of it. But when I did so, it got it went completely off screen. Now my tripod isn't the best. I need a new tripod, but with the Orion, like you can't really, it's hard to find. They're out of business. I went to Found Cloudy Nights. It takes you 3 months to post a question in there. So didn't know if anybody had any input on those two things.
Yeah, I mean, my initial reactions are don't clean anything, never clean anything. And then the second one is, do you have we can give you better. I'm just giving you the quick version. The, do you have a tracker? Is your telescope moving or do you have to manually move it every time?
If I'm in like an open field, it's much better than my little backyard. So I can zero in on 3 stars and then it'll follow it. You know, it's a go-to.
So it
But
does have a go-to.
yes,
Okay.
yes. But you're saying not to clean it too? You're still kissing off the
Well,
dust? Or are you joking? Joking.
I mean,
no, like it
yeah, it
depends on
depends
which
how bad it is.
mirror. Is it if it's not bothering your pictures? I have dust. People look at the bottom of my telescope and they're like, it's got dust on it. I'm like, that's because I use it, you know? But and I don't want to mess anything up. So if it doesn't need to be cleaned, I
Yeah.
don't worry about a little bit of dust. But if you're
Okay.
seeing stuff in your images and you're like, oh yeah,
Okay. Okay.
there used to be a place that would do telescope maintenance, but they're not open anymore.
Okay.
Sky's the limit.
All right.
I don't know if there's any other shops around. Do you guys know?
I don't know of any.
Okay.
Yeah, they
All right.
closed. They were in Pottstown. They closed about less than a year ago.
Okay. Thank you.
But
Any
You're
suggestions
talking
on
about
that?
Sky's Unlimited?
that's what I was thinking. But they're not
Yeah.
open.
Yeah.
Okay.
Mike, unless that mirror is absolutely filthy, I think I would be really careful about touching it, you know?
Mhm, mhm.
Maybe a couple blasts of air first,
Yeah.
just to see if that makes the difference.
All I ever use.
You look at
Yeah,
Doug's got that
Doug,
bubble. There, you can do a
Yeah.
few little things, but
Doug, hold up the bubble again.
Yeah, it
I
looks
got
like
one
a
of those.
spaceship, but it's a puffer.
Yeah, I
Right.
have one of those that's smaller for my camera. So I got to get a
Right.
bigger one.
Yeah.
Okay. Thank you.
And
And
the
any
other thing is,
suggestion on the movement of maybe I moved the telescope when I was trying to get the star into the computer better, but I don't think I did, but I don't know why it just disappeared on me.
yeah. Michael,
I
there
mean,
are also ways.
I'm sorry, Joe, go ahead.
That's okay. There are also ways to mount Orion telescopes, usually when other types of mounts.
Okay.
So if the mount is the issue, you know, you're not married
Yeah.
to. I have an Orion telescope that mounts on a Los Mandy mount.
What kind of mount?
A Los Mandy. I mean, not that you need to use a Los Mandy. There are other mounts that are probably even better.
And
You
it's
know,
LOS, Manny. Sorry.
yes, but I mean, I would consider maybe Los Mandy mounts are old, and I don't know about the longevity of that company. I think, but I mean, there are other companies like you guys would probably know as well as I. Maybe Ioptron might be a good. You know, ZWO makes smart mounts. You know, I mean,
Thank you.
that would take some investigating, but if it's a problem with the mount, you don't need to have an Orion telescope on an Orion mount. There are ways to mount it
Right.
there are ways to, you know, do otherwise,
Thank
you
you.
know.
Thanks.
Sure.
But I put a couple names in the chat, but it could be that your mount, yeah, if you don't do the polar alignment just perfectly,
Right.
it's very common for stuff to drift a little bit, and it's part of the fun of this hobby is figuring out where the heck it went.
Mhm, mhm.
You're out there, yeah. And tonight's a great night. Like moon imaging is like great
Right.
to get going
Right.
because it's harder to
Right.
miss. And
Right.
we all, yeah. So, but yeah, keep at it. And then if it's still having trouble, we get some more details on the exact part numbers you're talking about, that kind of
Okay.
stuff.
Thank you so much. I'm done. Thanks.
Yeah.
You're welcome. So it looks like we have some new members tonight. So or new attendees. I keep saying members. Sorry about that. You don't have to be a club member, just attending the meeting. So if you wouldn't mind, maybe just take a minute to introduce yourself and maybe give us a little bit of information about your background. You know, how advanced are you and things like that. So who wants to start?
I'll go. I guess so. I just went. My name's Michael. I live in Sharon Hill, Delaware County. I love astronomy ever since I was like a little boy. Saw Derek Pitts on it with Franklin Institute. You know, and I went down there, learned stuff as a little boy, and I just loved it. Probably should have studied that in college, but I did business instead. I've been like just viewing. I never got into astrophotography. I knew and known about it for years, but this is the first time I'm getting involved in it. I just got a camera from ZWO about a month ago. So I'm I'm a beginner. I know.
Which camera did you get?
Um,
Right.
I got it in the other room. I can't remember the name right now.
Okay,
I can.
yeah, that's fine.
Yep. Yep. But I know basic things in astronomy, like the waxing moon, the moon, and the waning moon. I know the phases of Venus and the red planet Mars, and I've seen Jupiter from my telescope, saw the cloud bands and things like that, and Saturn's moons and all that.
Fantastic.
Thank you.
Awesome.
Welcome.
Thank you.
Welcome, Mike.
Thank you.
Bill, Bill Telfer, you said this is your first time here?
Yeah, this is my first time as well. Kind of similar to Michael, I've been interested for a long time and just decided I might give it a try again and see if I could stress my wife out by adding another hobby. So I am an amateur radio license, so I play with radios and antennas and things. So that kind of is one of my passions too. But I've been kind of looking at astronomy to try and figure out you the amateur radio operators do bouncing off the moon, and they bounce signals off of meteor scouters and things like that. And as I was looking up at the sky about a month ago, I decided, well, maybe I should actually look more at the actual objects instead of the radio waves bouncing off of them. So
Very nice.
and I'm looking at maybe buying a C Star 50 because I'm lazy, and I thought it'd be a nice entryway to get into the astrophotography area.
Yeah, definitely, definitely. Well, you're in good company with a lot of the other people that on these sessions with the even with even more advanced astrophotography gear. A lot of people have like the dwarf or the S50 or S30 stuff like that. So they're certainly not mutually exclusive, and it's also a way to get, like you say, get your feet wet with it. Fantastic. Welcome.
And I live in Abington, so I just
Okay.
Hmm.
Okay. And so it looks like Harvey O's iPhone.
Yeah, can you see me at all?
Yeah.
We can.
Oh, yeah. How you doing?
Good.
Yeah,
Yeah.
I've been doing
We can see you. You look like a
astrophotography.
TikTok video. but-
Yeah, unfortunately, I couldn't get my iPad to sign on for some reason, but my cell phone did. Um, yeah, so we want to know what the history is on the astrophotography, right?
Well, just
Um,
general background, in terms
Yeah,
of
I've been doing it I'm an ex-member from about 2 years ago. I rejoined just recently, and I've been doing astrophotography since then. And trying to keep it simple. I do all the imaging with a ASI Air Plus and a Celestron C8, and pretty much I own like 3 different telescopes, so that I'm just using the Celestron now, do all my imaging, and using a couple of processing programs like GIMP and Auto Stacker. I use
okay.
that, and I produced some pretty decent photos, but I'm having issues. I think probably with back focus might be just a little off, and I'm getting uh, stars that look like they're slightly elongated. I don't think I have tilt in the system, but I don't have anything in the optical train other than a filter wheel, an automatic filter wheel. I have that, and the camera I'm using is old 1600 ASI Air 1600, and there's some amp glow, but it's not serious.
Is it a mono camera? You said you have a filter.
Yeah, it's a mono camera. Yeah,
Nice.
So the
I do all black and white images, and I use GIMP to color combine all the filters,
okay.
and that's what I've been doing for the last couple of years. We're trying to improve on the imaging, and just I'm actually getting ready to build a second scope, and I'm going to get an AS Air Mini to run that one
Okay,
and go from there.
fantastic.
Yeah. So the last thing I was imaging this week, I was doing the Tulip Nebula in Cygnus, and I do have a question. Is it better to take multiple small imaging sessions, like 10 seconds instead of 2 minute frames? So like I did 120 10-second frames on the Tulip Nebula. And the reason I did that is because when I did the 120 seconds, I was getting distorted stars. I'm
Okay.
thinking maybe the tracking wasn't that great as it's supposed to be. And
Are you
I have a
guiding? And are you
yeah,
guiding?
the guiding, yeah.
Hmm.
Well, I have an old mount that I've been had for the last 5 years. It's an Orion AZ EQ something, you know. um, so that's what's been working.
I
It's,
mean, for certain things, obviously the less exposure time, the less chance there is for errors to creep in, for things to creep in, like you said, like
yeah.
tracking or guiding
Hmm.
errors. But
Yeah.
there is a trade-off because in order to get, you know, sort of more photons, you need more time. So
Hmm.
it also depends on how bright the area you're imaging from is. So
Well,
if you're like in the suburban skies or something like that, you probably
mhm.
don't want to be doing 5 minute exposures. You might be doing 1 or 2 minute exposures.
Yeah.
If you're in a dark sky area,
Well, I'm in a
you
Bortle.
can do longer ones.
Yeah, I'm in a Bortle 6 over here.
That's
I'm
about
in a
what I
Bortle
do.
6 over here.
Yeah,
Yeah,
I
and
routinely do 2 3 minute exposures from Bortle 6.
you
Just as
get
a
away
data
with that
point.
2 minutes, 120 seconds.
Yeah, I mean, it depends. If I'm shooting
Mm.
like the image I'm going to talk about tonight, the globular cluster M71, I only
Yeah.
I only did 1 minute exposures for those because they're even though it's a dim globular cluster, it's still
Hmm.
stars. It's not like I'm
Right.
trying to find some faint nebulosity somewhere. Um,
Okay.
if I'm doing narrowband, like you said, you have a camera with a filter wheel. If I'm
Hmm.
like any of the narrowband stuff, like the sulfur, oxygen, or hydrogen, I routinely do 3 minutes
Okay.
because the narrowband filters knock a lot of the light
Right
intensity.
then. I've
So
had a lot
I
of
routinely do
success with
three.
yeah. I've had a lot of success with H hydrogen sulfur is the toughest one. That takes a lot of time.
Yeah,
And I find that with the images I take with that, if it's not more than 2 minutes, the image is dark, and yeah, I have to do a lot of processing behind it.
yeah. Well, sulfur, not. I mean, the objects that were the nebula and stuff that you're imaging don't tend to have a lot of sulfur. Sulfur is
Uh-huh.
one of the lower. I mean, hydrogen and oxygen are the more predominant energies that are coming out of those things.
Yeah,
But
because
sulfur
that's all
will tend to be
reflection
good.
nebulas
What's
on the
that?
reflection nebulas.
Yeah, the reflection would have a lot of oxygen.
Okay,
Yeah. And then
gotcha.
emission nebula tend to have a lot of hydrogen. That would be like
Mm,
the H2 regions.
okay.
So
How many do you stack?
it really depends on the object, but the most I've done, which was recent, I didn't even finish processing it because we had some family issues come up
Mm,
recently. Um,
yeah.
but I have 30 hours of data of the
Ooh,
Pelican.
oh, gee. How
It's
many days?
it's the most I've ever done before that was about 9 hours worth of data. This was
Okay.
30 hours. I mean, we had that stretch of good weather, and even though the moon was out, I was shooting
Hmm.
narrowband, so I shot mostly mostly hydrogen and sulfur when the moon was full, and then when the
Hmm.
moon got less, I shot some RGB and I shot
Wow.
the oxygen. So I have 8 hours, around 8 hours each of hydrogen, oxygen, and sulfur. And then I have 6 hours of RGB, 2 hours each of RGB. I
Yeah.
process RGB 6 hours, and I'm happy with it. So I'm anxious to get
Mhm.
back to the oxygen and to the narrowband.
Mhm.
I'll probably have it done by the next meeting. I hope to show at the next meeting. But
You haven't
that's
had
a
any,
record for me.
you
By
don't have any issues with integration in regards to the different days that you take those images,
No,
and
it was
like the
somewhat.
temperature variant and all that doesn't prevent you from stacking them.
I used the cooling on the camera. I had it set to
Yeah.
-10 C, and I took everything at that. Um, I I think
You
it was
use
a total of
one set of
800.
flats.
I
You use one set of flats and darks, right?
the darks and bias are one set. The flats are for every filter. Every filter has its own flat.
Right, right.
Yeah.
That's the hard part.
I have seven flats.
Um,
But I
wow.
think it was 850 exposures, and the
So,
RGB were all 1 minute,
yeah.
and the narrowband were all 3 minutes.
Okay.
So we'll see
Yeah.
if
See,
how that
I
looks.
have a hard time. I try to stay within 2 minutes on all of my exposure so I don't get confused.
Two
Uh,
minutes is a good
but
time for
yeah,
Bortle 6.
yeah.
Yeah,
I've
2 minutes
managed to
is a
do
good
that.
number.
A couple of bright nebulas and some galaxies. I've gotten away with that.
Okay.
But I'm just trying a 10-second thing to see if I can get enough frames to stack to equal the 2 minute frame that I'm looking at,
Yeah.
and if it does any better.
Yeah, I mean, there are a number of people. John Limegruber here has
Also, I'll stack
has
5,000
set the
frames. I
record.
don't
Yeah.
care. I shoot 1 second. If you're shooting black and white mono and
Yeah.
you have a fairly fast scope and you're in bright skies, you can get away with under 5 seconds. Do
Okay.
whatever's working for you, honestly. And like if
Yeah.
you're
I
getting
got a
like,
reducer on my scope,
there you go.
so I'm getting somewhere around 6.5, I think, somewhere around the f8.
Yeah.
So I'm down from 2230 to 1280, I think.
If you're shooting luminance, you could get away with 30-second subs or
Yeah.
probably even 10 seconds.
Mm.
Just do an experiment one night. Shoot the moon, whatever. Shoot something and compare the two. You're not going to do 2 minutes on the moon, but
No,
you know what I'm saying.
I don't have I have a moon filter, but it's
Yeah,
not in my filter drawer. So
yeah. Don't do the moon.
yeah,
You're right. You're
I,
right.
I got that, but I understand. I do uh, take pictures of the brighter stars like Altair, Deneb, and Vega when I get those, and I have a limited sky in my courtyard. I got 3 buildings surrounding me, so I can pretty much look straight up,
Okay.
but I can't look too much to the east or west. South is okay. I get Saturn right now. I got Saturn in the late evening coming across that part of the sky, but it only get about an hour because I got a tree to the west in that gap. So I got, I'm limited to how much time I can take my photos. So that's why, most I get is I can get 3 hours before I lose either daylight shows up or I lose it in the trees.
Yeah, that's not bad.
So
That's not,
yeah.
we take what we can get.
Good.
Well, welcome to the meeting.
Yeah.
Yeah, thank you.
Yeah, I've got the same story, Harvey. But listen, now that Gary mentioned flats, I just wanted to show you guys. I was so proud of this. This
Oh,
little device, when you use for narrowband and you have to shoot flats with each filter. This is an Amazon light pad, LED light pad. Lots of air conditioner foam, glue, copious
wow.
amounts of air conditioner
Okay.
foam, and you just clamp it onto the dew shield of the C8
All
when
right,
you
Wow.
when you're done
MacGyver.
with your imaging run.
That's over 8 inches wide, I take it.
Yeah, well, you can stuff like a little rag in here. Like I've got a C6 also, so
Okay.
so it's adjustable.
Yeah.
But yeah, so
I use the same. I have a
that's
light
how
pad,
not
but I
how
have,
to make how to shoot flats and not make it kill you.
yeah, I understand that.
So
Um,
it looks like we have one other. Justin, you're new this meeting or this get together? Justin Williams.
Yeah, I guess I relatively do. Yeah. Like I said, yeah, it's been about probably a year and a half since I was joining these when Lou was running them. So
Oh, so you have been okay. Okay.
yeah,
Okay. Well, welcome back.
thank you.
Welcome back. Okay. So any other people that are joining this for the first time? It doesn't look like it. What I can see. I think that's everybody. Yeah. Cool. And John, you are recording, it looked like, right?
Yep, I went ahead and started it up at the half past, so we've been good.
Okay.
Hi, YouTube.
I'm not sure if I'm on YouTube or I'm on the Zoom, I think.
Oh, we're everywhere now.
Okay.
We're live.
Yeah, I'm gonna see. So I'm gonna try. So you guys should see a desktop.
Yeah,
Yeah.
glob in the middle.
Okay.
Oh, in fact,
Good.
that's funny. That's what we're going to talk about tonight.
Just-
That's a coincidence because it rotates
Yeah,
every couple minutes. Every 5 or so minutes it changes.
Cute. Mm.
That's funny. So for tonight's agenda, as I mentioned, we're going to try this starting early, like at 7 o'clock, for like newbie kind of questions.
Mhm.
For a question and answer session. And then we just did the introductions of new attendees. Tonight, I'm going to be showing that image that you just saw as my background of M71. This was shot from my backyard with around Bortle 6 or so. About an hour and a half of data, hour and 15 minutes of data, something like that. And then what we'll do is we'll open up the meeting to any new images or anything that people want to show, new equipment techniques or recent images. And then if there's any time, depending on how things run, we'll open it up to just general Q&A again. And we're going to run the meetings that way, or this way, for a while, just to make sure, and maybe forever, just to make sure that we're addressing the beginners kind of questions and then also more advanced questions. And then I do want to try to have some type of a topic or something that we discuss, not necessarily at each meeting, but hopefully at most meetings. So that's that. So what I'm going to do is I'm going to jump right into the M71 presentation because that'll give us a good sort of launching point if other stuff comes up and I'm going to pull this. Let's see, 1 second. Okay. And then I got to get this out of the way. Okay, so you guys can see that?
DVA workshop via Zoom.
You got it.
yep.
Okay, so let's see if my, guess I'll do it here. No, that's the wrong one. I'm going to just close that. Here we go. Not sure why that happened, but we're going to try this again. Let me pull this here. And I think it's F5. Yep, F5.
M71.
Now you got it.
There
Okay,
we go.
perfect.
Mm-hmm.
It still thinks my desktops are flipped, so sorry for the confusion. Okay, so tonight what I'm going to present is some acquisition and processing of the globular cluster M71. I'm going to just talk about the motivation behind it, and this is the parentheses is real. I was actually waiting to image something else, but it was behind the trees. and I had about an hour and a half to kill. And I thought, well, let me find something that's not behind the trees. And M71 was a good target, and I decided to shoot that. I'll talk about briefly the equipment that I used, and then the processing approach, how I went about processing it. And then I'm going to also talk a little bit about image scale, because that has come up a number of times in terms of image scale. And there's still, it's a topic that is sometimes hard to get your head around. So I want to give a more concrete example of what I mean, or what is meant by image scale. And then I'll go through a processing explanation and also demonstration. I have PixInsight fired up so we can, and I have all the image files sitting here, so we can certainly grab those images and look at them. So this is part of the motivation. About 3 years ago, almost it was 3 years ago yesterday. I was up at Blue Mountain Vista, and I had my C9 1/4 with my ASI 2600 MC one-shot color camera, cooled camera. And I thought, let me just try taking some deeper exposures. I hadn't done anything more than about 3 minutes, 2 or 3 minutes. And I just did an experiment, taking some 5-minute subs with that setup. Now, it's not that you would need a 5-minute sub for something like M13, which is a fairly bright globular cluster, but this was an experiment. And obviously, if stars like this, these bright stars here are going to saturate, but most of these stars are not super bright. And it turned out that they were not saturated. There were a handful of stars saturated at 5 minutes, but not the main target stars. And what I tried to do with this image, I've seen a lot of images of M13. And I've also, my background was visual observing and astrophotography, but I was a fairly serious visual observer for 20 years. And most of the pictures I had seen of M13 that went deep didn't really look a lot like M13 visually. The cores were way blown out. The filamentary structure of these cooler stars, these yellow stars here, didn't really stand out. So what I tried to do when I processed this is to make it more like what you would see, not that you would see this detail through a telescope, but if you squint and look at this image, it starts to have the characterization, this sort of characteristic structure of kind of like that flea looking, that sort of tick looking structure that M13 has, that are predominantly due to these cooler stars coming out. And I kind of like that. It was the first time, this was also the first time I used Blur Exterminator. And I had processed this without Blur Exterminator before I got that. And the Blur Exterminator made it look better because it tightened up all of those stars. So this was kind of a motivation. Let me see if I can do M13, which is a noticeably smaller, noticeably dimmer globular cluster, and still retain that character of kind of like what would it look like visually. So this is M71. I might have said M17. I meant to say 71. This is M71. And you can see right away it's in a much richer background star field. But you can tell this is about the same image scale. These are like the same magnification, same camera, same OTA. This is cropped slightly just to center it because I was a little bit off center when I framed it, but roughly the same image scale. So you can see, how significantly different those two globular clusters are. M71 happens to be one of these globular clusters that doesn't quite have its identity. It was originally, up until the 70s, M71 was listed as a dense open cluster. And then once they kind of looked at it again and got together and said, well, it's really a globular cluster. It fits into one of the classes of the sparse globular cluster class. So it's kind of somewhere in between. When you look at M13, obviously it's a dense, it's the largest one in our hemisphere. It's a dense globular cluster. This was shot with a C9 1/4, a Star Arizona 0.63x type 4 corrector. It's basically a focal reducer field flattener. ASI 2600 MC Pro camera, 60 millimeter guide scope. When I shot this, I think I actually had a 290. This is probably a mistake. I didn't update this from the other slide. It has an ASI 290 guide camera. Not that that makes a difference. It's a little bigger sensor. Ioptron C40 mount and a ZWI SIR Plus. This was shot about a month ago today, in my backyard. The SQL readings that night were about 19.13 to 19.19, 19.2. So Bortle 6 or 6.5 or something like that. And this I forgot to update. I'm really sorry. I'm sorry about that. This is shot. Sorry about that. I messed up. This is shot with 74 one-minute flats. Okay.
Mm-hmm.
I feel like fixing it real fast since I'm in the PowerPoint. So this is 74 one-minute flats. So it's an hour and 14 minutes worth of data. Okay. Calibrated with flats, starks, and biases, and this also has blur exterminator and noise exterminator applied to it. And we'll go through that. This is a zoomed in at that core, and keep in mind, one of the things I wanted to try to do here was have it be that kind of visual, somewhat visual, structural look to it. If you were to squint at this and then look at that, and then compare it to the core of M13, we can see much denser and much larger. This is the equipment that I used. So yeah, I have the camera correct here. So the ASI 240 mm. So this is the C9 1/4. This is actually not the 2600. This is a 533. But just picture the camera being a little bit bigger. Autofocus, EAF autofocus. The guide scope here, guide camera. The SEM 40 mount. And then the ASI Air is on the other side. I have that mounted here. And a lot of times what I do, I use this same setup for planetary work. With a different camera, with the I have an ASI 485 planetary camera, one-shot color. When I change the camera, that changes the balance of this, and you can certainly move the dovetail in the saddle, but if it's a small change, like going from the 533 to the 2600, a lot of times I just move the guide scope. That's what I use the balance to do fine balance on this. On the mount. As you can see, I have a dovetail bar here, and I just slide the guide scope back and forth. You can see there's a little clamp here, an adjustable clamp. That's a nice little trick. Sometimes you can move something else on your mount, on your OTA or something else, instead of struggling with loosening this and sliding this up 1/8 of an inch. Good luck with that. These are heavy, and there's a little bit of grab to it and everything. So that's a little trick. Even the ASI Air, I have that on a little cam kind of clamp. I can slide this back and forth if I need to fine tune the balance. So this is how I went about doing this. This is just my approach to processing this image. It's not based on any particular methods other than my experience and what I was trying to accomplish. It's meant as a guideline only. So feel free to experiment. There's a lot of ways to skin a cat. So feel free to experiment. The thing I was trying to accomplish is I wanted to image this and process it, M71, similarly to what I did on M13. I wanted to have that visual character of the globular cluster. I wanted to try to maintain that. I took 1-minute subs to avoid or reduce saturation of the brightest stars. I also wanted to avoid overstretching the globular cluster so that the core stars wouldn't be saturated. In that M13, a number of those core stars are saturated. It was stretched a little too much. And then I say this with, tongue in cheek, even at the expense of better eye candy. When you look at that M71 image, it's flat. It looks flat compared to a lot of astronomical images you just see. And that was intentional. It was intentional to not have it be eye candy as opposed to how can I really gauge what this thing looks like. So those core stars, there's nothing in that core saturated. If you run your cursor in PixInsight or something over all those stars, they're all up in the 80s and 90s, but nothing's pegged out. I wanted to keep things relatively basic for the purpose of this discussion, meaning that there's not super fancy tools involved. Almost any image processing software, Photoshop or GIMP or anything, they have curves, they have histogram, they have things like that. That's what the bulk of this was done with the exception of the blur exterminator, things like that. I used an optical tube and camera combination at its native image scale, and we'll talk about that in a little bit. That resulted in an oversampled image, and again, we'll talk about that a little more when we talk about image scale. That was intentional. You could easily have shot it that way and then binned it 2x2 when I did the processing, which would still not be an undersampled image. It would be actually probably nominally if I did 2x2 binning. But I intentionally left this oversampled because I wanted to get kind of as much data as I could, as many pixels on those stars as I could. I wasn't as concerned about signal to noise ratio because they're stars. It's not like I'm looking for faint nebulosity. It's not like I'm trying to eke out some really subtle details in something where signal noise ratio considerations would push you towards having a more nominally sampled image or a better matched image scale with your equipment. And again, we'll go into a little more detail with that afterwards. So, or maybe now. So image scale. This part of the discussion was prompted based on the comment below. This was what I made when I posted that M71 image in the middle of August. I said for the geeks out there or something like that, this combination of equipment results in an oversampled image scale. It's about half an arc second per pixel. That's oftentimes binned 2x2. However, for this image, I did not do any binning in post-processing because the scene was fairly good that night, which means you can get away with a little smaller image scale. And because I also wanted to have high spatial resolution, since the target was a dense star cluster located in that star field. So for reference, that Star Arizona reducer flattener used on that OTA is about a 1500 and change millimeter focal length, about f 6.45 effective. That gives that image scale of about 0.5 arc seconds per pixel. So how do you calculate that? So image scale is really how much of the sky in arc seconds is represented on each pixel of the sensor. That's really what it is. And it has to do with how many radians are in a circle and all that kind of stuff. So if you go through the math, the equation is fairly simple. Your sampling in arc seconds per pixel is equal to 206, and it's like 206.1265 or something, but 206 is plenty close enough, times the pixel size in micrometers divided by the focal length of your optical tube. So that would be the OTA plus the focal reducer, that 1515 in this particular case. And for and there are calculators. I have some links here for some online calculators if you don't feel like, you know, doing the multiplication and the division, to find that, to calculate it for your equipment. But there are some general rules of thumb, and the way it always used to be stated, like for years, was that you use a pixel resolution of about 1/2 the typical seeing condition. So if your seeing is 4 arc seconds because of turbulence in the atmosphere, then for deep sky work, your image scale of 2 arc seconds per pixel is reasonable. That particular night had better than average seeing. Not certainly 1/2 an arc second per pixel seeing, but it would have been okay for that lower number, that 1 1/4. And you'll see all kinds of different rules of thumb. You'll see 1 to 2, you'll see 1 1/4 to 1 5/8 arc seconds. It's all, who cares? It's all in the ballpark. It's close enough for jazz. So that's a good general rule of thumb, though, if you're trying to match your camera to your scope, to shoot for numbers in that range, say 1 to 2 arc seconds. Because our seeing in this area is probably 2 or 3 arc seconds, I would say, on average. And on a really good night, maybe it's sub 2 or something, or 1.5. If you're on top of a mountain in South America, you can have sub arc second accuracy. Or if you're on top of a mountain, you know, somewhere else, you can have sub arc second seeing. Not so much when you're at ground level here. For planetary work, the rules are very different. You want to have really kind of a lot of resolution, basically. You want to have an image scale, again, depending on your seeing, in that 0.25 to 0.5 arc seconds per pixel. So what does that mean? So if we look at the two optical setups that I had, now I shot this just recently, just the other night for this presentation, with my TV85 with my mono camera. So this is a mono image, this is a color, but it's luminance, and this is RGB, you know, basically one-shot color. So they're comparable on a pixel basis. It's the same sensor in a mono camera versus a color camera. So the same number of pixels on each sensor. So this is 1.5, or I'm sorry, 1.6 arc seconds per pixel, and this is about 0.5 arc seconds per pixel. So you can right away see that for the same sensor size, that this is a much bigger field of view, which you would expect, right? There's a lot more area, 3 times the area roughly on each pixel. So let's zoom in on this. So now I'm going to take these stars, like right in here. There's a couple stars right there. We're going to look at that. I'm going to zoom way in. Same images, mono, one-shot color, but this here is this star. So in the 1.6 arc seconds per pixel, you have about 4 or so pixels on that star. And that's actually pretty close to nominal sampling for this object. Because if the seeing was 2 arc seconds, you would want to sample at roughly twice that. You'd want to have twice as many pixels for sampling theory as you would what that spatial resolution that the atmosphere is allowing you to see is. If you look here, there's way too many pixels on that star, but for the purposes of what I was trying to do, that's okay. It's bright. they're not saturated, even though they are bright. This is stretched at this point. With a screen transfer function. This isn't processed. These are the only thing done to these images was a gradient correction. That's the only thing done to these. So these are raw stacked images, no noise reduction, no sharpening of the stars, nothing, just a gradient correction. You can see here, these three stars resolve very, very well, right? On the high image scale. These are those same three stars. They sort of blur somewhat together at that scale. At this scale, they don't, because we're not as zoomed in. So this looks fine at that zoom. At this, it's like, man, what's going on with that left image? If you zoom in a little more, you can really get to see what's going on. So you have here, 1, 2, 3, 4, 5, 6, 7, roughly 7, 8 pixels across compared to, and it even blends into here, blends more into the background. So there might be 9 pixels compared to these 4, something like that. Same with this. You look at how many pixels are involved in that star compared to that. Now, if you're oversampled like this, what you sacrifice is signal to noise ratio, because you're spreading the light over too many pixels. And that's why you have this sort of nominal sampling of 1.25 to 2 arc seconds per pixel for deep sky work, so that you kind of find the sweet spot between signal to noise, not spreading your signal over too many pixels, and also having enough samples so that your spatial accuracy doesn't develop artifacts. So in basic sampling theory, you want to be able to have enough samples to accurately represent the thing that you're trying to capture. And I can go a lot deeper into that, but we're not going to for the purpose of this in terms of sampling theory. So you can see here that this is probably a little bit light. This is 1.6. And it was good seeing that night. I could have probably gone down to 1 or 1.25. And this is certainly too many, but it doesn't really matter because they're bright objects, and that's what I'm trying to capture, and I wanted that spatial resolution. So as far as learning more about this in general, one site that I recommend is this Starizona site, and we can put these. You can do a screen grab of this or something, or just Google Starizona, getting the most detail, or you can do image scale. What are the best settings? You'll come up with some of these links. There's also a CCD calculator in this astronomy tools, and then a CCD suitability where it'll tell you whether you're oversampled, undersampled. There's a little scale that I guess I don't have my browser here. Okay. And then this is a forum discussion where one of the forum members gave a really good explanation. He'd had a bunch of sample images of, showing different spatial resolutions, what you can see, what you can't see, artifacts that are introduced, things like that. It just happened to be a particularly good forum discussion on it. So that's that. Are there any quick questions related to that, or should I keep going and we'll come back to stuff later? Okay, I'll keep motoring. So this is M71, and then I'm going to go through how I process that. I also have PixInsight open. So, excuse me, I did screenshots of this showing each step. and so that we would have it as a reference. I'll probably put a PDF of this or something up on the website in the documents section under presentations, so that at least it's there. I'll correct those couple typos where I forgot to update those 2 line items. So this is the image, and this is how I got there. So I used PixInsight for this, for everything. And the linear part of the processing, meaning before I stretched anything, was done by using PixInsight's weighted batch pre-processing. So I loaded up my lights, my flat, master flat, master bias, master dark, and I let it do its thing for 40 minutes or whatever, and it spit out a master file. Excuse me, a master file. First thing I did was a gradient correction on that. I then did a spectrophotometric color calibration. I then ran blur exterminator and noise exterminator, and I had still a sort of partially processed linear image.
Which gradient correction did you use, Gary?
I used that one, just the one that they introduced last year. That's just the gradient correction. I a lot of times use the multi-point one. Let me see if I can. I don't know if I bring that down. Okay, it'll keep its place there. So there's a lot of times that I do this dynamic background extraction, gradient correction, but I've been relying more and more on just the straight gradient correction in PixInsight, and I tend to use it at the defaults. It's rare that I play around with the defaults, so this is at its defaults. This one left a little bit. This one left a little bit of gradient that'll be in the corners, and I'll show you that when we get to the images. But yeah, just that one. And one of the reasons for that is because it was in a fairly dense star field, and I just didn't feel like playing around with dropping all the points in between the dark spaces in there. So I just did and the gradient didn't look that bad initially. So that's what I wound up doing.
Thanks.
You're welcome. So for nonlinear processing, I took the linear image. I did histogram transformation on that. I did a generalized hyperbolic stretch. I then reset, and I set the black point with some latitude, and I'll show you that. I then did curves to just bring out a little more of the sort of dimmer stars in the core, not touching any of the brighter stars. I did another curves to improve contrast and goose the saturation a tiny bit. Just boost that a little bit, bring out the star colors a little more. I did another black point correction. I unfortunately had the scope was just a tiny bit off center when I started imaging, and I thought that's fine, I'll just crop it. So I did a very small crop, as you'll see, to just center the globular cluster. Another black point correction. Actually, I'm sorry, this. Yeah, this might be duplicated. This one, I think it was curves, crop, and then black points. So I'll fix this. There weren't 2 black points after the crop. There was just one. It was the one after the crop. So this one I actually did after the crop. Then this is an optional thing. I actually did it looked like there was a little bit of red background noise. Now this is in an area where there is some background nebulosity, but I just wanted to put this in just to show the group the technique. And this is optional, very subtle difference. I did a slight I did a range mask and then a slight background red reduction to get rid of just a tiny bit of that little hint of red, and then that was the final image. So if you go through those steps, this is the gradient correction. So you can see here, this is the original image. This is like pre-gradient, post-gradient correction. And you can see here, there's still a little bit of gradient in those corners. Compared to this, it's better. It's certainly better, but there's still a little bit. These are flat, these are calibrated with flats also. I knew I was going to be cropping this a little because you can see it's a little bit off center. So I knew I'd be kind of lopping that anyway. And I thought that's good enough for the purposes of this processing, because the thing that I'm really interested in is that core, even though it isn't a really nice star field. So Steve, this is just that same gradient correction tool with the defaults. I then did a spectrophotometric color calibration. And this is pre-calibration on the left. This is post-calibration on the right. You can see that it's not drastic. It's a subtle difference when you use the screen transfer function, but you do see a difference in there. These are a little more yellow. This has a little more red in it. And same with this star. You can't see it over here, but it does make a difference, and I do that routinely. I do the spectrophotometric. One thing to note with spectrophotometric color calibration is that you can, for a lot of sensors that are used in these common cameras, you can pick the sensor. So if you're in PixInsight, let me just drop an image in there. So this is the gradient corrected image. And if you open up the spectrophotometric color calibration and you look at this pull down, you can see they have a number of sensors in there that you can use for if you don't want to just use the generic, like this ideal quantum efficiency curve. I used to use that until I realized that, oh, well, the 2600 uses the 571 sensor, and the 533 uses the 533 sensor. I'm just going to put the right thing in there. The other nice thing too, and this was a forum discussion that just was, I don't know, earlier today or yesterday, maybe yesterday, when Dan Stern was commenting on John's image, and he talked about extracting RGB, or extracting like kind of equivalent or pseudo RGB stars from narrowband data. Well, I've actually done that. I didn't reply to that thread because I was kind of busy putting this together. But you can actually go in here and you can put in narrowband filters, and you can choose narrowband mode. And you can put in the actual filter specs. These are my filter specs for the Antlia filters I have. And it'll do a decent job of color correcting, even for narrowband data. So that is something to keep in mind, that tools like this, and I know from what I heard, Cyril now has the spectrophotometric color calibration.
Yeah,
So,
thanks. Everything you just said makes sense. Cyril has a menu that looks just like this, and I've never seen this. So this helps me a lot, exactly with what you have with the wavelength and bandwidth and narrowband.
yeah.
So this is beautiful. Thank you.
And it isn't going to make RGB stars, but it will get you close, so that if you do the trick where they're a little bit magenta looking, because they have the magenta rings, and then you invert the image,
Yeah.
subtract out the green, do
Green
like
noise.
an SCNR green, and then you invert it back, it gets rid of a lot of that.
Yeah.
I've had good success with that. So just keep that in mind. So there are things you can play with in this. I don't touch anything else. A lot of these are at defaults, except for stretching, things like that, the blur exterminator. So back to this. So the next thing I did was blur exterminator. And on this one, I increased the star halo adjustment a tiny bit, about 20%. I think it defaults to 0.1 or something. And I left the intensity at how aggressive the blur extermination technique is at its default of 0.5. Most of what I do, I pull that down. I actually pull that down. But because it was a globular cluster, and I really wanted to highlight those stars, and because I did that on M13, because I didn't know any better when I first got Blur Exterminator to what these things even did. So I just kind of did it at the default. I left that at the 0.5. So you can see the difference. The left is the pre-blur exterminator, the right is the pre-blur exterminator. So even though my stars are round, it's not like I'm using them to correct streak stars or something like that. You can see it really does tighten things up significantly. This could have been put to 0, this sharpened non-stellar, because there really is no non-stellar stuff that I'm looking at here. But I left it at the default because it's not going to matter if there's nothing there kind of thing. And you can see here, if you take a look at these icons that I drop on the desktop, I do that routinely when I use PixInsight. Once I do an operation, I grab this little triangle here and I make an instance on the desktop. And that's actually my history. If I need to reprocess it from any step, like let's say I went too far with the non-linear stuff, I'll open up the image before and I'll just go to that step and then tweak it to kind of take care of that. Next thing I did was a little bit of noise exterminator. This is pulled back a little bit. It's a little more aggressive than I typically do. I think it defaults to 90%. So I have these at 80% and this is at 65%. And you can see it does clean up. It cleans up that background nicely. But if you look at the stars really are not that affected. I mean, I don't really see much of anything because they're bright. So the signal noise ratio of a star is generally not a problem. But I wanted to clean up that background. So I left it a little bit heavier than I typically use. But I'm okay with that for this purpose. The next step is, and up to that point, everything is still linear. I haven't stretched anything. Every image you're seeing here is with the screen transfer function. So none of it's stretched. Once we go to a histogram transformation, though, you can see that now we go into this nonlinear world. So this is the image. If you look at this image here, this one that's with the noise exterminator. That's the same image as this one on the left that looks black. It's because I've turned the screen transfer function off because I'm going to stretch it now. So I did three histogram transformations of this setting. A lot of times I'll do 1 or 2 and then I'll change the setting depending. The goal I'm trying to reach is to get that histogram, get the stuff of interest somewhere in this kind of range here, not quite like maybe the 20-25% point on that scale. I kind of want to bring that out of the mud, out of the dark, so I can start to work on that and then stretch this so that I can get more kind of information out of these stars that are kind of in this, and they're really actually more in this region.
Hey, Gary.
Some of those in here, yes.
Maybe it's just me, but I feel like we skipped a step. So when you went from linear to this looks like nonlinear, what was the step for doing that?
That's the histogram transformation step.
Right.
That makes it nonlinear. So now I'm stretching that data to bring up those the faint
So
information.
it looks like you've already done some stretching though.
This is stretched 3 times
Okay.
with this transfer function. So let me do this, Steve. Let's just go to this real quick. So if I go to Pixen's site, I'm going to grab that pre-stretched image, right? I'm going to turn off the screen transfer function. So that's the last linear thing that we're going to have here. I'm going to open up the histogram transformation. I'm going to bring up the histogram, and I'll bring up a preview window. So right now, that preview window is showing what that image would look like with this amount of stretch, with doing that, around there. Right? If I don't stretch it at all, if I zero that, I think 0.5 is the center. So if I put that, or let me just reset it. If I reset it, that's the same as that. So now I'm going to stretch that. I'm going to pull that over, and you can see the stars come. If I stretch it, if I go really too far, right, you can see that coming over, and you can see the different lines showing up. But it's too much to do in one operation. So if you bring it part way, I can see a little bit of a stretch there. I'm going to apply that. I'm going to apply that to the image. Now, if I stretch it again, it'll look like this preview. It'll go from that to this. So if I do that again, it's going to say, oh, what's it going to look like if I do it a third time? It's going to look like this preview window. I can turn that off and on. So it'll go from that to this if I apply it a third time. So let's do that. So I apply it a third time. Now this is a little heavier than what I did when I processed it the first time. You can see that the histogram is now right at this 33% point. Whereas when I brought it up, I'm sorry, I got to get rid of this. I don't want to save that. Oh, I'm sorry. Yeah, I want to close it, but I don't want to save it. So if I bring up that same noise exterminator, I'm going to turn it off, the screen preview. I'm going to bring up the histogram that I used. You can see it was a little bit less aggressive, and I'm going to do it 3 times. I'm going to apply it 3 times to this image.
So when you turned it off, what linked that data to the histogram transformation? In other words, maybe there's just different ways of doing things here. I have always taken the caret from the screen transfer function and dragged it up to the histogram transfer function and dropped it in the bottom line to bring that information into it.
Correct. That's very common technique. So let me show you what happens when you do that. So I'm going to bring this, I'm going to just minimize that. I'm going to bring up that same image, right? So now I have this. I'm going to reset this. I'm going to drag that triangle into the histogram. And then I'm going to apply that. And it looks exactly like it did when I brought it up, because it's taking whatever the screen transfer function thought was just a representative image so you can see what you're working on, and then made the histogram actually apply that to the image.
But you don't have to do that.
No. In fact, I never do that.
Okay.
I did it years ago, but I never do that anymore because it's way too aggressive.
Okay.
It's way too aggressive for my taste. I'm not saying it's the wrong way to do it. It's just for my taste. I'd rather have the control of being able to eke it out the way that I want. And I'm gonna show you that here. I'm gonna just continue with this. So close it anyway. Yeah. So we're gonna I'm going to close that. I just don't want to accidentally overwrite one of my master files. I do have them. I do have them backed up. So this is as far as I went with the histogram, and you can see how different that looks compared to, like if I bring up the screen transfer function. This is what you would get, or what I would have gotten if I used what you just said. You know, you drag the triangle onto the histogram. This is what I'm going to start with instead of this.
But
And
how do you get it into there? It's just because it's an active window? How did the information get into that?
Oh, I mean, when you bring up the histogram transfer,
Yeah.
the transformation, every time I drop, like if I want to stretch this more, I can just drop that in again.
So is it linked because you have it checked down at the bottom? Is it?
No, it's right here. If you look here, it tells you what it's working on.
Okay.
See the little line item here?
Yeah.
That's what it's representing.
All right. So you can just start there.
Yeah, like if I throw another image up here and I'll turn off the screen. Oh, if I don't even need to turn that off, but if I pull this drop down, you can see there's two images here. There's two pull downs here.
All right. Got it. Thanks.
That would be
Yep.
that histogram. And in fact, this is interesting. If I stretch that a little more, just for the hell of it, this is before spectrophotometric color calibration.
Yeah.
Look how unaligned the RGB channels are. That's what
Well, how do you get those back aligned other than you have to go back to one of those tools?
well, if I pull up the spectrophotometric color calibration image, the one that's calibrated, I'm going to shut that off. I'm going to select that. Oh, it is selected here. I'm going to pull that over. You can see that they're lined up now.
Right.
And that's what that's doing. That's what spectrophotometric color calibration is doing. It's basically making those stars. It's basically doing a white balance on those stars based on the way the stars actually look, based on scientific data on those
Yep.
stars. I can show you the trick. So if you look at a histogram, let's look at this one. And I'm going to, that's way too aggressive. Oh, actually, I'm sorry. Let's look at this one. Let's look at the one that's not color calibrated. So I'm going to turn that off. I'm going to do a couple stretches just to get the histogram somewhere.
So when you said turn that off, I missed what you were doing.
Oh, okay. I
Turn it
turned
off
off
where?
the screen transfer function. So when you open up anything in PixInsight initially, it automatically applies. Well, it doesn't automatically apply, but here, I'm going to do this. I'm going to go back to the master file. This is the master file that came out. When I first started this, the image looked like this. This is the master light, stacked light. I opened up the screen transfer function. I unchecked it. I unlinked it because it's not color calibrated yet. I don't want to apply this screen transfer function in an equal way to each of the RGB channels, or else it'll look like, I'll show you the difference. If I leave that checked and I hit the radioactive button, there's way too much green, right?
Right.
Typical. So I'm going to reset that. I'm going to uncheck that linked button and I'm going to do the radioactive symbol. Now I have a better color balanced thing to work with. If I were to do a histogram transformation on this, I'm going to now turn that off.
Where?
This little icon
Okay, up there.
turns it off.
All right. So
Um,
you could have done that down at the screen transfer function also, right?
correct.
Okay.
Correct. Yeah. Oh yeah. 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 I see. As opposed to
Down
you.
in the bottom right-hand corner.
Yeah. 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 Sorry about that. Yeah. Yeah. You can do that. Yeah. You
All
can
right. I'm
you
just
can
trying to follow what you're doing. That's all.
Sure.
Sorry.
No. 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 They're good questions. Yeah. You can just reset it.
Yeah. Okay.
If you reset it, it's the same as turning it off.
All right. Gotcha.
Yeah.
I'm good.
So now if I were to stretch this, I got to turn it off first. If I were to stretch this and then stretch it again, you can see that they're way out of whack. You can go in. I can go into the red channel and I can bring this slider over
Hmm.
to line that up. I can then go into the blue channel and I can bring this slider over. And then I can go back to RGB. I can adjust sort of the black point of that. But you can see it's still not right because the red channel's too wide. The histogram's too wide, and you can see that it's bleeding red all over the place.
Yeah.
That's what that spectrophotometric color calibration takes care of. It does it in sort of a scientific way as opposed to trying to tweak these sliders for each individual channel to either move or compress those curves.
Yeah. Okay. I'm
Right?
good. I
can
didn't
do
mean
that,
to.
and then I can do this. That makes it narrower. So, follow? We're going to get rid of that. I do not want to save that.
Gary,
Yes.
quick question. Screen transfer function, is that only in PixInsight or does that exist in like the Deep Sky Stack or a similar function?
I don't know about Deep Sky Stacker. I don't. It's been a really long time since I used that.
Hmm.
I it might be called something like auto stretch.
Okay.
That's also another thing. Like if you look at the ASI Air or something, or you look at some of those things, it's an auto stretch.
It's auto stretch and serial too. I never knew what screen transfer was.
It's
Okay.
basically auto stretch.
Yeah.
Okay.
It just gives you something that you can see rather than having a black thing that you're working on trying to guess what's there. The
So-
next thing I did was this generalized hyperbolic stretch. And the way I do that, this is actually what I used. I'm going to show you the preview of that, of what I actually used. And then how I got to there, I'm going to reset this. Typically what I do, and you don't have to use the GHS, you can use like the ArcSine H stretch, or you can you could use curves. Curves is another thing that can get you there. The nice thing with the hyperbolic stretch is it kind of incorporates a couple different actions in one tool. So what I typically do is I put the cursor somewhere in the background. If I zoom in on this, I just kind of pick sort of a background area. And then I set that, it's called the symmetry point. It basically is setting where the stretching is going to occur around. It's kind of the point the stretching is going to occur around. And I try to get it, if you see this is the histogram here. If I were to point in the brighter areas, like in the core, if I happen to hit a star or something like that, it puts it way up. Well, I don't want to stretch that. I don't want to stretch this star. I want to stretch faint information in this area. So if you do it sort of in the background, it sort of puts it around the middle of that curve. So I'm going to send that to the symmetry point. And all it did was it took that value and stuck it here. You can do it by moving this slider to there. You can do it by typing in a number. It's just easier to do that. The next thing you do is you apply a stretch. So I'm going to start to stretch that. Let me put a preview up. I'm going to start to stretch that data. And it's kind of stretching it around that symmetry point. You can see that that curve, that histogram curve is getting wider about its center. But what can happen here is you can start to blow out those core stars. If I look at the values of these, they're at 99.8%. You know, numbers like that, way too high, way too hot. I'm basically saturated. Those are saturated right now. If you can see those little numbers, 0.9999, and you'll get to 1 if you, there you go. Everything's 1. That's too hot. It's too much stretch. I don't want to blow out all those stars. A nice thing with the generalized hyperbolic stretch is I can protect those highlights by pulling this protect highlights slider down. And you can see what it's doing is it's keeping a stretch, but it's pulling the curve down in this area. So that now if I go to those, they're still too hot, but because I have the stretch too much. But they're not saturated anymore. So you can kind of work the highlights by protecting them. You can even protect the shadows, but generally speaking, you don't have to protect the shadows because there is some information in there, and we've already kind of how do I want to put it? The black point's fairly well behaved coming into this. We're going to adjust the black point separately later, so I'm not too concerned about protecting the shadows. And I'm generally not playing with that slider. I'm always protecting the highlights so I don't blow out bright features because I don't want to stretch the real bright stuff. And then I have I typically a lot of times do a more moderate stretch like that. And then I do this thing called local intensity, which will just bring up sort of the middle of that curve. And if I check here, you can see I'm getting there, but now I'm only like 94, 95%, 97% in the very center. So I'm still not saturated. And then I would apply that function. So this is the one I used. I'm going to apply that. So that would be applied to that image. So now we're at this point. We're not saturated. I'm about 97, 90. Looks like the peak is right around maybe 98, 98.7, something like that. But you can see it's way too gray. So then the next thing is to do a black point on that. So I'm going to pull up the histogram. So this is the histogram before a black point is adjusted. That's this bottom curve. And all I'm doing is moving this slider to kind of get some of that gray out and get some of that background lightness out without doing anything to really clip this. If you bring that slider over, it looks better initially. Like if I zoom in here, oh, it's nice and dark. But the problem is now you're clipping information. Now you're basically losing information. So I want to make sure that that black point is always below the bottom tail of this. And if you were hunting faint nebulosity, you would even have a little more tail because there's going to be some information in there that you don't want to lose yet until you do a little more stretching. So the only thing I'm going to do, I'm just going to open it again. So when we apply it, it's kind of what I did before. So that's now with the black point adjusted. The next thing I did was a second curves pass, a first curves pass. So curves is a really cool function because it allows you to tweak individual areas of the image. So a lot of times what I'll do is I'll kind of go to the background and I'll find out where that background is. And you can see I dropped two little points here. Those are protecting any of that faint information. One little trick with curves is if you put 2 points right next to one another and then you stick a point in the middle, I can do anything with that point, right? Blow the heck out of that image. It didn't affect anything on the bright side. It didn't affect anything on the dark side. If I lose one of those points on each, you can see what it does. It pivots around each individual point. So now, as I'm moving this, you can see those little tails are moving too. And curves is your friend. Curves is a great tool. It's the way processing was done before PixInsight and before Images Plus and all that stuff. When you use just Photoshop, you basically had a histogram and you had curves, and you could get all these same effects with those two tools. They're just a little more time consuming and not as convenient. So I'm going to open that again so that I retain my settings. So that's the preview window. So what I did here was I took this, and all I wanted to do, I actually zoomed in that region, and all I wanted to do with this operation was just bring a little more of those. Oopsie, sorry. I grabbed the wrong thing. All I want to do is just bring up a little bit more of these stars, these kind of halo stars. They're not really halo stars in this sense. They're part of the core because this is a fairly sparse core. But all I'm trying to do is just bring up a tiny bit of that middle section. I don't want to blow out anything. I don't want to affect anything here. I don't want to do anything in the darks yet. So again, I'm going to do it this way so that I retain my stuff. So I'm going to apply that.
Gary, quick question.
Yes.
On the third point that you put in on the curves thing, is there should it always be kind of in the middle, or is there some thought of where you would put that?
Yeah, it really depends on the object, Sandy. With this object, I only have really one point. If I'm working with nebulosity and stuff, I'll have a bunch of points on here. And you can typically what I do is I'll do something like this. I'll look at the preview window and then just drop in a point and see what it does. Push it way up, see what it does. And you can see that it actually does, it brings out a little more eye candy in this. I'm going to do that on a second step. If I let me reset it and just show you. So if I click here, the information in that part of the picture lies. You can see those little lines shooting around. That's where that information lies. So if I drop the point there, and then let me put 2 points here and here. If I pull that up, it's grab. You can see it looks horrible because it's posterized now, but it's grabbing that sort of dark background and pulling that up. If I were to put a point here and pull that down, you can see that it's reducing that background. And then if I put a point here and pull that up, what have I just done? I've just increased the contrast of that image. I've just brought the highs up a little bit, and I brought the lows down a little bit. And as a lead into the next step, that's exactly what I did here. This is the histogram. I put a point there, I pulled it down, I put a point there. I'm going to show you the preview. And then I went to the saturation setting and I pulled that saturation up just a tiny bit, just to give me a little bit more color in those stars.
So the other curve is the first curve you did. That's on that.
Yeah, so if I go to RGB, this is the RGB curve.
Oh, okay.
If I reset it, it's the image I start with. You can put a point here, pull it down a little, put a point here, pull it up a little. One key thing is don't do too much on any one step.
Yeah, this is just like in the Photoshop way.
Yeah.
The old way. Okay.
Yeah, this is basically the old way, but it's still very, very effective because you have a lot of control. And then what I did was I went to the saturation and I just pulled it up a little bit. I don't want to overdo it. So if I go preview off, preview on, it's got a little more pop. The background's a little darker to give you that a little more pop. And the star colors, if I zoom way in, you can see the stars just come up a little bit.
Sharper.
Yeah. Yeah, even though we're not playing with sharpness,
All right.
it's all contrast. It's all shifting contrast.
Great. Thanks.
You're welcome. So I'm gonna open it up again and then apply that. So that's that image. The next thing I did was I cropped it because I'm not sure why I was off center on that. Usually I'm better than that, but whatever. Close enough for jazz. So then I cropped it. Then I did another plate solving on it. And then the last thing I did was a final black point adjustment. You can see off, on. It's subtle. That's black point adjustment off, black point adjustment on. And then I applied that. And at this point, I'll blow it up. At this point, I was pretty happy with it. It's not overdone. Stars are still not saturated. They're getting close. I saw a 0.99 in there, but still not saturated. The other thing I thought was kind of cool was in this region, there is some kind of wispy stuff going on in the background. So if I were to bring that black point, if we look at that region there, we look at that sort of wispy stuff in there, and don't be afraid to zoom way in. If we look at that wispy stuff there, and I were to pull that black point far, you can see where the stars are, right? They're up there. You can see everything goes away when I pull that black point up. So a lot of the information in this image is way outside that histogram. Right? If I look at the full image, so here's the whole thing. Now I'm going to move the black point. I'm just going to throw away any information darker than where that slider is. And by looking at this top curve, you can see what that's, where that is. I'm going to grab that black point slider. So I've like totally blown away most of that histogram, right? And look how much information is still there. It's all this real low stuff. If you kind of zoom in on that, you can see it's still above the axis. That's all those stars. So that's kind of what you're working with. I'm going to reset that, reset this. No, I'm going to go the other way. Now, the last thing I did with it was I said, it looks like there's a fair amount of red in the background. Now, again, I only have an hour and 14 minutes of data here. So this is not a lot of data. They're, you know, the 74 1-minute exposures. I actually did a range selection and just grabbed the stars. So the range selection is just a tool that's typical in you know, in Photoshop and Searle. And I basically you can see kind of how it works. Let me go back to the full image. If I move the sliders, I want the upper limit to be the same. I don't want to lose any bright stuff in it. I want the bright stuff. So the upper limit is 1. And then the lower limit, I kind of adjusted until I got the bulk of the core and those stars. So if I zoom in, the background is unselected and the stars and the area around the stars is. I didn't want to lose the halos. So I wound up, you know, trying to make sure I got those halos. So that's kind of where I wound up. And then I applied that. So I made the mask, and this is the mask, and then I applied the mask to this image. So the way you do that in PixInsight is you grab it, and then you you grab it and then you drop it on to the toolbar, or not the toolbar, to the sidebar here. And then right now the stars are, stop it. The stars are what's showing. So I have to invert that mask. And now only the background's showing. And then what I did was I did an SCNR. I cut it back a little. It's usually, I think when it's reset, it's at 100%. I did like 70%.
And what does the SCNR stand for again?
It's in that slideshow. Hold on. Something way too complicated.
I think
It's subtractive chromians, SCNR, subtractive chromatic noise reduction.
okay. 'Cause I know one of the books I'm reading on PixInsight, yeah, they give you that when they first started, but then everything else, I have to keep going back. Now, what the hell is that?
Yeah.
Yeah.
So I'm gonna hide the masks because we don't need to see all the red. And then I'm going to drop this SCNR onto that image. And it's done. So if I go back and then I go forward, it's hard to tell zoomed in. And you might not even be able to see it on the zoom. But it just took a little bit of the red out. If I were to go like 100%, let me do that. I'll do 100% just to show you.
Here, you have green selected.
Oh, I'm sorry. I reset it. That's why. Sorry about that. That's why it's not showing any difference in red. So let me go back to this. Undo SCNR. We want that. So let me zoom in here and I'll drop it on. Yeah, now actually now you can see it. That's at 100%. So that's post red reduction. That's pre-red reduction. Post and pre. It's very subtle. There it is with it reduced. There it is without it reduced. Actually, look at this. Look at this right here. Look at this thing right there. That little that star or whatever that is. You can see that. Now that's a lot. I did it at 0.7 about. It was 0.69, I think. So if I drop that on, it's a fairly subtle difference. And I tell you, once I did that, I kind of liked it before doing that. So I'm not even sure I would, keep that step in there. And then so that's that step. And then the final image again. So that's that.
Very good, Gary. Thanks.
So what step, Gary, did you do any of the noise reduction stuff?
Noise,
is that
noise
like-
reduction I did
With the
really
blur
early on.
exterminator?
That was right after the blur exterminator.
Oh, okay.
So there's the just the blur exterminator, and then that's with the noise reduction. So it's really was the fourth step. If I zoom in here, that's with noise reduction. That's without.
And that was in linear or non-linear?
Linear.
That was in linear when you
Yeah,
did
that's
that.
a linear.
Okay. Okay.
Yeah, so if you go back to that spreadsheet, not the spreadsheet, the PowerPoint I meant to say, that's still in the linear. And if you look at these icons here at the bottom, this is the gradient correction, color calibration, blur exterminator, noise exterminator, the 3 passes of the histogram, the hyperbolic stretch, black point adjustment, the first curves to bring up the center of the core, or the stars kind of in that core without blowing it out, and then the contrast tweak with the saturation crop, black point, and then that red thing, the red trick. So fairly straightforward. Now you might ask, well, wouldn't a lot of people, they remove the stars, and for a lot of stuff that makes sense when you're dealing with when what you're processing is the background, like for nebulosity, things of that sort. Get the stars out of the way, sure. But for something like a globular cluster, it actually, I think it makes it look worse if you try to process them separately, because the background becomes too foreground. Basically, it becomes too dominant. And I'm going to move the people over here, so I'm actually looking towards the camera. So it winds up being like too much, too much of the foreground. So we still have we have time for a couple questions, or I would like to see some other stuff. But to get the ball rolling, I want to show one quick thing, which Dan McCauley, who I was thinking might be on this meeting tonight, had talked about some of these dark features that he likes to image. And there was this one that he posted recently that I had seen before, but I wasn't sure if it was like this other thing I was thinking of. And I had mentioned it to him, and there was a little bit of back and forth with this thread. It's called the Sandworm Nebula. And I thought, I don't even know if I could shoot this. He's shooting from a little darker location, maybe Bortle 5, Bortle 4 sometimes. I'm Bortle 6, 6.5 or something. And I thought, I wonder if I can even see something like that. So I had a little time on while I was waiting for something else, and I pointed the C9.25 to this. It's called LBN 438, or sometimes nicknamed the sandworm. And this is about 2 hours and 30 minutes worth of data. And if you look at the actual 2 hours of 30 minutes, like when I looked at all the individual frames, there was nothing there. So any of the lights, any of the individual this is a 3-minute, this is a 2 hours and 30 minutes worth of data, but any of the 3-minute subs, there was absolutely nothing there. And I thought, well, I think this is going to be a waste of time, but I'm going to do it anyway. The scope's running, I'm just going to do it anyway. And I was really surprised because when I first stacked them all, This is with a screen transfer function, which is a fairly aggressive stretch. And that's all that you can see with that. And then you compare it to that. Oops. So it went from that to that with some histogram curves, you know, GHS, the same basic stuff that I showed you with the stars removed first. There's a lot of nebulosity in this area. So this is one that begs for, you know, more data. You can see how noisy it is. It's begging for more data. But it was encouraging that even in a Bortle 6, even in a Bortle 6.5 sky, you can pull stuff out of it. Like surprisingly, you can pull stuff out of it. Let me just go to PixInsight real fast. I'm going to pull up an individual light.
This was with the one-shot color?
Yeah, one shot color.
Nice.
That's an individual light. And let's do the screen transfer function.
Nothing there.
So on any individual frame, without you know, and this is aggressive. This is an aggressive stretch. There's nothing there. There's absolutely nothing there. But 2.5 hours worth of that, guess what? Stuff comes out. So where's my thing for stop sharing? Here we go. So thank you.
Nice.
Great. Hey, Gary, question. So on the one that you didn't see anything on the light frame, I'm guessing the way you knew you were in the right location was by plate solving?
Yeah.
Okay.
And in fact, that object wasn't even in the database. So I couldn't even know definitively. So I just matched, I did what you used to do when I was looking through a telescope. I matched the star field. I went on the stellarium and I matched the star field. And I said, yeah, I think that's where it's supposed to be. And I kept taking frames and I kept looking at the subs saying, this is a waste of time. I don't even know why I'm doing this. I should move to something else that I'm going to see. But I thought, well, it's an experiment. You got you know, this is how you learn. What can you do? What can't you do?
What
So
constellation was it in?
it's in it's let me pull it up. So I guess it's near. Yeah, I think it's near Lacerda. So it's kind of in between Pegasus and Lacerda, I think. And it like now it's like or not now, but like midnight or 1 o'clock in the morning, it's like right at the zenith.
Very good.
It's really, really high up. And it's LBN 438. Yeah, so this is where's the zoom thing? So this is so that's it there. And this is like at 1 in the morning. That's zenith. So here's Pegasus here, Lacerda. So it's in that area. And I think the thing he shot was on the other side. Was on the other side. It's somewhere over here. I think it's this. It's at this area here. Yep. Somewhere in this area. There's all this this dusty stuff. This is stellarium. There's a bunch of it in this area. There's some of these dark nebula. But this is what I was going for, that one.
So weird.
Yeah. So even in bright locations with enough time, I mean, if you threw another 2 or 3 hours on that, it would be noticeably better. You get rid of some of that noise. So, what other images we have? I know, Mark, you've been doing some stuff still. Um, you posted that one recently, right? With the North America?
Um, yeah, I did. I did something in the elephant trunk area recently. Um, I'll try to pull it up if you want to look at it.
And John, you have that dual band, right? Or
Yeah.
not dual band, but I mean the two narrow band.
Yeah. I think Mark did the greater region, so that's a good way to start.
Let's see.
And Joe, we're always wondering what's going on out in Texas.
I have a couple of images.
Oh,
Hey, Joe, how is Lou's telescope coming along?
I have a short report on that
Okay,
also.
right.
Okay.
So
Can you
whenever,
guys see that?
Not yet.
yeah.
Should have permission to share. Let me know.
Uh, oh, thought I was sharing. Do you see that?
Mm-mm.
No.
If you want, I can share real quick. I have it up.
Yeah, go ahead, John.
Let's see here. I'll just share the whole desktop.
I don't know what I'm doing.
Okay. Can you guys see that now?
Yeah.
Yeah, I'm pretty sure this is the one. Is that correct?
Yeah.
Because you got the elephant trunk coming in. You go ahead.
Yeah, because you did the whole nebula.
Yeah, that's with my dwarf. It's a mosaic. It's a four panel. I did like 90 minutes uh data on each of the panels and the dwarf, stitches it together for you. When it first came out, I wish I could share. I don't know why I'm not able to do this.
Yeah, sorry, this is only the JPEG, so yours is going to be better. Yeah.
Yeah. Um, I'm hitting the share button here. It says someone else is sharing.
Oh, that's because I'm doing it. If you
Oh,
got it that
now
far,
it
I'll
is. Yeah.
stop. Now you try that button.
Okay, I'll try again. Okay, I guess keep bringing it up. Can you see that? No.
No, it's missing a step, like where you hit whole desktop or just a window.
I'm very illiterate. Sorry.
Are you doing great?
I'll try one more time. I'm hitting the share button, but maybe I need to bring my. I don't know. I I'll try to learn how to do that better for next month. But yeah, it was a four panel thing. That you set the dwarf up, and it kind of its base settings in its screen is like a 1 by 1.1 by 1.1, and I just opened it up to a 1.2 by 1.8. I don't think you can go bigger than 1.8. What those numbers relate to, I really don't know. It's just what it says in its settings. So anyway, it opens up the field of view and got it kind of centered in there and took it. It was oh gosh, what 6 hours worth of data if you really think about it. It's an hour and a half on all four. It usually takes like I was doing 30-second exposures, and it would do like 20 exposures in one panel area, and then it switches to the next panel area, does another 20, through all four, and then just starts repeating the cycle again. Um, and then it stitches it together, and it didn't look all that great. And so then the dwarf's got that auto, I guess it's called Stellar Studio, which is pretty nice. It does I usually do two things on it. I do a star reduction or correction. It's called star correction, and then a noise reduction. And that brings out a pretty nice image. Still not super great looking, because the nebula is still really, really faint. Uh, so then I took that and I moved it into Serial. I just took the JPEG that came out. It's got all the fits there, but I don't know how to do all that stuff yet. So I just took the JPEG, popped that into Serial, and then ran took the stars out. I got that thing where it's star remover thing.
Darnet, yeah.
So I took the stars out and then played with the histogram on the nebula, stretched that out, just like we were doing there tonight. Just the basic histogram, stretch that out, and that brings out a lot. And then adjust the black point a little bit to darken it up. And then I pop the stars back into it, and then I reduced the stars when I put it back in. I think I took it down to like took 30% out, from 100, and took 30% of the brightness of the stars out in that particular one. And then there you go. Save that as a JPEG again and pop that back in, and then I just got this real basic Microsoft designer thing. I don't On that one. I don't think I did anything, but sometimes I put it in there, and they got these like little filter color things you can put in there or whatever, and like it's called punch or radiant or warm cold.
Right.
But yeah, that one I just left as it was.
Came out
So
good.
that's what I got.
That's great. The
Yeah.
dwarf and EQ mode's pretty interesting.
Yeah, the dwarfs, it's not a super great thing, but you do all that other processing on it. There's actually a lot of data there if you can know how to. I'm sure there's even more that I just don't know how to do anything with yet. But we'll get there.
You're doing great.
Thank you.
John, you have your
Yeah, I'll show mine real quick. I know we're running a little long. So I'm just gonna zoom in. So this was the image Mark was just talking about. And so I'm zoomed in. I'm just gonna be looking at this piece right here, basically. And that's what I got pulled up here. I got this up at Green Lane Park. I saw Wayne and Barb out there. And I did 2 hours. I start off with hydrogen alpha because it's usually a little bit brighter earlier in the night. And then I switched the filter manually over to the O3 filter. Got another 2 hours. And I was doing a lot of auto focusing that night. It was a little rough. It probably took 6 hours to get the 4 hours by the time of all the faffing around. And but I was happy with how it came out. And like Gary was saying, I cheated. Your options are usually have very colorless, very bland white stars, or you can kind of try to recover a little bit of star color. So you can at least see they're like if it's a warmer star or a cooler star. But yeah, it's not perfect, you know. Don't look at my stars too close. But I love these little Bach globules, they're called.
Yeah.
So my personal taste is I really enjoy trying to pull out a lot of detail. And so I also shoot a little bit oversampled. This is 1 arc second per pixel. And I find that these days it's better, in my opinion, purely, to be a little bit oversampled and make up for it using the like blur exterminator type stuff. Because if you use that, it'll you can kind of cheat and you can see better than seeing. And so I did some sharpening too with the wavelet transforms. Um, it's all up in here. So this is Cyril that have open here. And there's all kinds of filters. So it's got the wavelet transforms just like the planetary guys use. You can come in here and like crank that up way too high. But I'll just add a little bit to it.
So that
This is
would,
already processed, but so there's a lot of stuff in here, and the newest feature for any serial people is that spectrophotometric color calibration. That's a new option we have to play with. So, but I'll leave it at that.
John, the wavelets are basically like what you would use in Registacks for planetary?
Yep. So I'll use it on just the nebulosity part. So I'll go into my starless. So this was it earlier on, like right after star extraction. And you'll see there's actually some artifacts here. The star extraction is not perfect. So it pulls over some of these halos and things.
No, yeah.
So that's what gets blown out. So you can even come here. I'm jumping around a lot. Let's look at something here. Image processing, filters, wavelets, execute. I never use the first and last layers. The first one just makes it super noisy because it's like per pixel. The last one just makes it super bright because it's the whole image. But if you can just go into like 1.2, 1.2, 1 point, I don't know, 1.5, 1.1, there you go. You got a sharper image and you can preview on and off just like Gary was doing. You can't see much here. But you get the idea.
Yeah, yeah.
I'll do that to
It
pull.
doesn't seem to introduce much noise.
Yeah, and then I pull more noise out later at the very end. So with mine, instead of blur exterminator at the beginning, my software Uber Smooth works in the non-linear mode at the very end. So because it's kind of grainy if you look in there. But okay, I'll leave it
John,
there.
what software do you use to actually get the image?
I use Nina.
Okay, you're using Nina. Okay,
Yep.
thanks.
Yeah, Nina's got a lot of automation. I have my laptop sitting out there connected with a ton of USB cables. It's not that elegant.
It
Bring extra
obviously
USB
worked.
cables.
Yeah, I have a picture to share. Uh, here, let's see. Is
There it is.
that coming up?
Yep.
Yeah.
Oh, okay. Well, um, I don't want that. Okay. Okay. Yeah, here's my picture from Green Lane. Can you see that?
Yeah.
Yeah.
Okay. That's from two sessions. It's two frames. I used the ASI Air to do the mosaic. And the first time I realized that I had to figure out how to rotate the camera right because ended up with the pictures not lined up well and big rectangular black areas that if I cropped it out, I would have had to crop too much. So I went out the second time with John and was out there. I sort of figured out how to rotate the camera and it came out much better. And then I managed to combine both nights off 4 sets of data. And it's only a matter of about 80 to 90 minutes of the data, but it knitted together well and just cropped a small amount of the top and bottom. And so that's why I got of the lagoon and the Triffid nebula. And of course, the challenge is trying to figure out how to want the colors, how intense you want the colors to be, and all. And that's a matter of personal preference. And borrowing my wife's eyes for the color vision because I have troubles with that. But that's what I ended up with. So.
Nice.
Nice.
What camera is this? Which camera?
That's the ASI 500, 533.
Okay. So that's why, so the crop, so yeah, the top and bottom is why it's rectangular. Because that's the square sensor, right?
Right, right. So I had,
The mosaic. Yeah.
Yeah.
yeah. So, yeah, I had to crop a little bit of the top and the bottom, but it's basically two frames.
Yeah, the two side by, the two objects side by
Right.
side. Yeah,
But I
yeah.
had to, I found out I had to have to go to preview in order to figure out how to rotate the camera to get the mosaic frames to line up properly, and then the plan view to do the imaging after that. But first time I didn't know that, and so that wasn't right.
So the morning,
Yeah. So anyway, that was a learning process. So now I have an idea how to do mosaics
That's cool.
on the SIR.
It seems like it'd be tricky to get them side by side. That's what threw me off because they're in the sky, they're kind of like this. M8, right, and M20.
Well, yeah, M20 is above. So
Right.
when if I get this printed, I'll print it vertical.
No. I just mean to get the camera lined up right so that
Oh,
when you move it, you're getting
right,
both.
yeah.
The camera had to be
Well,
twisted,
first
right?
time, the first night they were like this, and so that meant I had a big black area in the upper left and lower
Yeah,
right. And so I thought I need to do better. So I went out a second time that I wasn't playing on, and that's when John was there. And I got the camera rotated enough so that the two halves lined up better.
yeah, that's nice. Good job.
So
That's tricky to do.
it's in there, but it's not well documented. You know.
Very nice. Very nice, Wayne.
Good, Wayne. Very nice.
Looks like Harvey. Oh, sorry. I'm trying to unmute. Oh, sorry. Go ahead. Harvey pulled a picture up here. There you go.
Yeah, the ghost of Cassiopeia.
We see it.
Yeah, that's like 3 days worth of imaging on all hydrogen alpha with deep sky stacker.
Wow. I see.
I took that about 3 weeks ago, I believe.
Very nice.
Yeah, I was surprised at the detail I got out of that.
Yeah,
Pretty
yeah.
ghostly.
I
Very
like
ghostly.
that.
Yeah,
That is ghosty.
Yeah,
a
I
little
like
bit
that.
of
I like that a
cell
lot.
phone in there too.
Yeah.
iPhone imaging processing also.
Oh, wow.
That's how I got the wording on there, the letters and all that.
Yeah.
Very nice.
That's really close to a very bright star. That's
Yeah.
cool.
That's
Yeah,
nice.
I
I
forget
like
to
the
start
framing.
it really lights that nebula up. I want to
Yeah.
do a color image at some point. When I get around to that. Anybody else ever take that picture?
I haven't done this one.
I haven't imaged that, no.
Never heard of it.
Ghost of Cassiopeia. It's in the Cassiopeia star constellation.
It's right in the middle.
Yep.
That's cool.
And what
There's
was
another.
that?
There's like 2 sections of it, which is pretty cool.
That's
I
pretty
managed to
good.
get that image.
That's pretty good.
All right.
Very, very nice.
Thank you.
Sweet.
I'm doing something right.
Yeah.
Definitely.
Yeah, it's just
Doing something right just to find it, you know?
Yeah, you got this going.
Beautiful.
Okay.
Nice presentation.
Yeah.
Did you mention, Joe, that you had a quick update on some things?
Yeah. Yeah, but do we have time?
Yeah, go for it. We'll
Okay,
probably call it that after this, unless anyone's got burning. Go ahead.
Oh, I can't get one right now.
One sec. Let me
Yeah, take your time.
Yeah, Harry needs to close his.
right, I'm trying to help him, but there you go.
There we go. Great. Here we go.
You still working out good with that setup, Joe?
Yeah, yeah, yeah.
You
Yeah,
got your
pretty-
guide, you got your guide scope working again, Joe?
Yeah, that was that was a comedy of ours. But yeah, the short answer is yes,
Okay.
everything's but yeah, one guide script later and didn't really need to.
Oh dear.
Yeah, but you don't have an hour. So
Okay. Yeah, fair.
anyway,
Offline we'll chat about that.
right, that's right. That's right. That's right. Over drinks, preferably. But
Like
I
many.
wanted to mention to everyone very quickly that Lou of course passed away a couple months ago tragically. And when we were at the viewing, for Lou, we had the idea maybe dedicating a telescope from our group, our astrophotography group, to kind of honor him a little bit. And at the same time, the uh, the the solar telescope that we had really wasn't performing. We had a Daystar that had a heater, and it's for some reason it just never was on band. And people were using that telescope and coming back and really complaining about it and really frustrated with it. So the idea we came up with was to replace the scope and maybe kind of make it a little memorial for Lou. And so we ordered it, and it took a couple of months, but it came in about 2 weeks ago. And I just want to show you. There's some pictures of it. Not a very large scope. It's a 50 millimeter scope, put out by Lunt. It has a 6 millimeter blocking filter on there. And it is photography compatible because of the size of the blocker. And that's a picture taken by Tom Nolasco with it. I gave it to him to kind of run through its paces, and he had a couple surprises with it a little bit. One of them was trying to reach focus with the camera, and he found out, and there's not much written on this, I guess. You have to take off this little guy right here before you attach a camera. But he wound up taking a couple of really nice pictures, and I'm hoping to maybe have a little presentation at one of the meetings. And I'm going to in the middle of writing a letter to Missy, his wife, and just telling her what we did. And we also talked about maybe making a plaque of some kind for the scope, but the scope is really small. So I have a feeling it comes in a really nice carrying case. So I'm trying to figure out how to do something on the case to just kind of, more memorialize it a little bit for Lou. So that's where we are right now. It's going to come with an Altaz mount, but we also have donated many years ago, and it was in Lewis's garage for about 10 years, and he finally found it under, I don't know, under something. But I got it to work. And so it can be compatible. I have to buy an adapter, but it will be compatible with this scope. So it will be available for photography, and it'll be in rentals, and we can also use it for outreach. So it looks very, very promising based on these images that Tom took. So I'm hoping to have it back from Tom at the meeting next Friday night. So that's that.
Nice.
I have a couple of images if you guys are interested, just real quick. I don't know.
Joe, quick question before you move on. Do you guys, are you looking for donations towards this thing?
Well, yeah, I mean, I think a couple of donations have been made already towards it. But donations are always welcome if someone would like to make a small donation towards it.
Now, who do we give it to? To you?
Scott, that guy right there.
Me.
Okay.
I'm the treasurer, so
He's the
Oh, yeah.
treasurer.
Okay. Well, that's what I'm saying at the meeting.
Right.
Yeah,
And he
'cause I-
hasn't
I-
been,
Yeah, I was gonna say I'm going to be stuck down in Florida for the next meeting, so I guess miss the
Right.
picnic. But the meeting
Yeah.
after that, I'll bring a thing to take care of
Oh,
that
that'd be
stuff.
great. Yeah.
I think you can also do it through the website. I'm not quite sure, but I'm pretty sure there's a donation link on the website. So
Yeah, you can make a
but we can
donation through the
coordinate
website if you so desire. So, but it's sponsored by us, and I think it'll be really, really nice to have, and I think it would be a nice. It's going to be a nice tribute for Lou. So he did a lot for us, even despite his illnesses, he really was a trooper to the end, and really was, very upbeat and enthusiastic, and so that's good.
Joe,
Yeah.
what mount did you say you're going to put it on?
It's an Ioptron, and it's about 2015 vintage, but I got it to work, and I kind of did some razzmatazz with the power supply. So it's going to have what do you call it, a cigarette lighter jack kind of affair, and it'll run. Um, and I managed to do that without burning out too much of the electronics. So it does run, and we should be okay,
Okay.
So anyway, but see and show. There we go.
In the room yet. We just checked out.
Yeah.
So you got your remote rig data.
Huh. Let me see. Sorry about that. So these are a couple of images. I'm just going to go through them really quick.
Here you go.
Here we go. Okay. So these are just a couple from Texas, and I thought I would just go through them real quick. I know it's late.
Yeah, no,
This is one. This is the Row Ophite complex. It involves the star Antares and M4, and a number of other objects. There's a nebulosity around Sigma Scorpii as well. And this is just a detail. And I kind of always like this area of the sky, in a dark sky, it's really kind of cool. This is the dust nebula around the star Antares. And this is M4, of course, which is the closest globular. And then in the distance here is, let's see, I keep forgetting, NGC 6144. So M4 is about 6,000 light years. And this other little globular here is about 33,000 light years. So M4 is the closest globular to us. And so that's one. And
that's a great area.
It's beautiful, it really is. So
that's shot with the small refractor.
Yeah, 400 millimeter lens. Oh, that's a 4-panel, by the way. I shot that over I think I spent about 7 nights on it, but only 4 nights where I got data. So it's 5.5 hours per panel of the 4 panels. And this is the other one. This is, of course, the Veil Nebula complex that I did. This is a 2-panel mosaic.
You got that? You got 2 panel of that with a 400 millimeter. What?
Yeah.
533 was. What's the camera?
It's a 400 millimeter Ascar.
And the camera?
It's a 5-element. It's a quintuplet. It
No,
doesn't
the
have
camera. The camera. So that's a 2600.
I'm sorry. It's a 2600. So it's a
Wow.
1-shot color camera.
Oh, you got that in two panels. That's
2 panels
beautiful.
for this, 4 panels for the other.
Yeah.
So, and I hadn't really shot much in the way of mosaics. It's a little trickier than I thought, because even out there in Texas, the skies are usually pretty dark, but the conditions do change from one to the other. And with that one on Antares, it was 4 panels, but I spent 3 nights just getting the last panel. It just something would always happen, and clouds would move in. So the last one was a little bit tricky, but so. That's that, and I think that's North American Nebula, single panel. So,
Joe, did you process all 4 panels? Did you combine them first, like merge them and then process, or process the 4 panels?
What I did some preliminary stuff, and then they were in linear mode when I combined them. Um, or you know what I did? I'm sorry. There was a slight stretch on each one, and I was really careful to have the stretch exactly the same on each of the subs. But I didn't do much until I combined them, and then I did the rest of the processing.
And you mentioned, Joe, you did all one panel and then moved on to the next panel the next night or whatever. Because
Yeah,
I'm doing the
you
same.
know, and
And
I probably, if I had to do it again, I probably would have split it up. I mean, I know other people do that. Um, but I just thought it easier, you know, and I didn't have much experience doing panels, but I would spend, you know, there's only about 5 hours or so. I was shooting in the middle of the summer, 5 hours or so of darkness. So I would shoot 100 3-minute subs, I think, for most of that. I started when I first got the rig in Texas. I was shooting 3-minute subs with it, and I found out when I got to the Cygnus area that I was oversaturating the stars. You know, the stars are so bright, some of them, that so I went down to 2-minute subs, but that was all shot with 3-minute subs. But usually 100 3-minute subs per, which took about 5 hours per panel.
Great.
very
Yeah.
nice. Thank you.
Oh, thanks. Thank you. Yeah, but so that's it.
Amazing how rich that star field is. You look at that.
Yeah.
Oh, it's so beautiful.
Oh, it's
You know,
insane.
yeah. And I mean, I think any, you know, many of you and you know, many of us could shoot these from here. I think the advantage down there are the, you know, more clear nights than here. You know, I'm usually getting about maybe at least 10 or 12 clear nights a month, you know, without the moon. Um,
Sure,
and
the dew isn't as bad.
Well, the dew isn't as bad, but there still is dew. Like I still have to run dew heaters down there. You know, I never had a dewing incident, but they say that, you know, you really should run a dew heater with your equipment just in case. So, and I don't have a field rotator. I don't. So, what I do is like I even just look in atlases sometimes and try to figure out, you know, how am I going to do it, and then I'll actually, you know, set everything up in the ASI Air. I'm only shooting in ASI Air down there. I'm not using Nina or anything like that. I'm not using a PC. I'm just using an ASI Air, which seems to be working out just great. But I know that probably the best way to do it would be to do it with Nina. You know, and the more versatile way to do
It's
it.
got a lot of automation options, but it's pretty steep learning curve too. I haven't touched a lot of it. So,
Right.
yeah.
Right. Yeah. And I was just lazy, you know, and
You're smart. You got images.
Oh, yeah.
thanks. Well, you know, I got that rig, and every night I would come home and I would rewire it, and I would rewire it. I think I rewired it for about an entire month, like 30 times, you know, because I was so afraid I was going to get a snag or something like that. And I was really kind of worried about nothing, you know, and you think you're going to send it down there and everybody's going to know more than you do. And but you know, it actually was very straightforward, and the people down there at Starfront were really very, very nice, you know, and very helpful. So, and I was worried about, you know, getting images off of there. I didn't know how to do that. But it all was very, very straightforward, much more straightforward than I thought. And Steve, you have images from there as well. I mean, what did you think?
Yeah, I think it's a great place. They have a good setup.
Yeah,
Now my telescope is tiny. It's an S30, but
right.
you know, I did it that way because that's what I could afford, really.
Yeah. Well, I think they have many, many sea stars down there at this
But
point.
I still had issues. You know,
Right.
you're always going to have issues with no
Right.
matter what you have.
Right.
And if it's not in your backyard, then you got to deal with it 2,000 miles away.
Exactly right. Yeah. Yeah. I was having an auto guiding problem, but I think it was related to the mount, not to the auto guider. But when you're, you know, 1,500 miles away, you really don't know. So I shipped a new auto guider down there, a
Yeah.
new auto guide scope down there. As it turns out, I probably didn't need it.
But I'm really happy with it. I mean, just a number of nights that I can
Yeah.
do something.
Yeah.
You
And
know,
shooting with the ASI Air, I mean, it's not, I guess it's not as convenient as using Nina. I have to set up a new plan every night, but after you do that for a while, the plans become relatively easy to set up. It only takes about 10 minutes for me to go through it, and it's kind of cookbook. I use the same exposures every night, the same cooling. So it's not so bad.
But the moon down there is really, really bright when it's out.
Yes.
It's almost like noon
Right.
during the day.
Yeah, yeah. I shoot in the other part of the sky, and I usually like shoot clusters or things like that, not nebulae when the moon is out.
Yeah, that makes sense.
So try to do what I can, but there's still a moon down there. I mean, yeah, you can't get away from the moon.
They'll fix that next year.
Yeah, that's right.
Yeah, they'll get rid of the moon.
Right.
Put the
Right.
moon filter out there.
Yeah.
That's
So,
nice.
Yeah.
I like that Row Ofukai area. That's just a gorgeous area.
It's so beautiful, and I never really, I mean, I've seen it on photographs, but other than really, really very wide field, I never really shot it, so that was one of my goals to shoot that
Came out
this
great.
summer.
Joe, for your
Thanks.
Veil Nebula, how much overlap did your two-panel mosaic have?
I use at least 20%. That's what they recommend, at least 20%.
Because you said it's a 400 millimeter lens.
Yeah.
Because I have 344 and I can get it all in a single shot. So I'm
Right.
surprised.
Well, I had a ton of overlap on it.
Okay.
Probably much more than I really needed. And a lot of times I'll actually get an idea of how many panels I need just by looking in an atlas. I've got a little card that has the size of the lens, and I'll just kind of, and then I'll feed everything into the ASI Air. I'll pick an object and then I'll adjust the declination and right ascension until I'm centered. So just so I don't miss something.
Scott, you're capturing all that in one panel with a 340 mil?
Yeah.
focal
I
length?
mean, I haven't processed it all, but yeah, Joe, if you stop, I can show you.
Oh yeah, sure. I'm sorry.
It's a
What camera is that?
The 2600, but it's a
Oh.
430 millimeter with a 0.8 producer, so comes out to 344. But yeah,
Yeah, I have a reducer
like a
for
really
that too, but I'm not using it. So I'm shooting at
gigantic
400.
screen. Yeah, I mean, so it's hard to see because it's in process, but there's the one side and there's the other
I'll be
side.
darn. Wow.
Yeah. So that's a raw image. I just got it the other night, so I haven't done anything with it. But yeah, I mean, and obviously it's closer to the eggs than you probably want with it, and it would be better to do a mosaic. But it was just kind of interesting that it's about the same size as what Joe had shown, and it's a single shot. So
Well, the other thing is I can't rotate.
Hmm.
My camera runs north-south, but I don't have a rotator on it. So
Yeah.
if something isn't, at the same declination, I have to kind of do some razzmatazz to try to get.
You wind up having to
Right.
cut stuff out because you
Right.
can't get it framed the way you want.
Yeah. And I didn't get a rotator because I kind of figured things that probably like a 20% chance of actually working anyway, like why make it more complicated yet, So I was thinking of doing that and getting I shot all my flats and everything before I went down there, the flats and the darks and the bias frames and everything. I made up a library at different temperatures, which was a good thing because I can't get down to -10 down there. And I did it at different, the darks at different exposures. And that was a good thing because I kind of figured I'd be shooting it, 3 minutes and I was shooting, I'm shooting now at less. But I might add some of those things later on, but it really hasn't been much of an issue.
That's good. That's good to hear that it's working out.
Yeah, thanks. Now the people there are really great, really nice. Couldn't be more helpful.
Yeah, because what happened, the last couple of weeks with that rare stretch of decent nights,
Right.
It's so rare around here anymore. It's just so
Right.
difficult.
Yeah, I was having some terrible guiding problems. But as it turns out, I think it's the mount, and I think it only happens when, and maybe I I was out of school the day where they talked about the AM5 mount, but whenever I'm shooting at zenith, whenever I start to shoot an object and it's at zenith, it doesn't track.
Joe, do you which version of the ASI Air software are you using?
Well, I just got the mount a couple months ago. It's the AM5N.
No, I'm at
Um,
the app, the which version of the app and what's on the Air. Because
you know,
there
I don't
was a
really.
problem. There was a problem with one of the versions. I had to look it up. I could look it up and send it to you, where they had issues with it guiding near zenith, and they actually sent an apology out, and then
Oh, is that right?
reverted. Yeah, and then you couldn't even get the newest version for a period of time,
Right.
like on the App Store, like with Apple, because they reverted back to an older version. But if you were stuck with the newer version, I didn't know there was an easy way to roll it back.
Yeah. I think I have the older version. I've had that ASI Air for several years now.
Well,
But
ASI
but
Air auto
but it
updates
would
though.
go ahead. What, Scott?
The ASI Air always auto updates. As long as you
Yeah.
update the app on your phone or your iPad, it'll
Right.
automatically push it down. It's actually kind of annoying that
Yeah.
you
Yeah.
don't want it to.
Yeah.
Well, I
It
think
was working for months, and then all of a
Yeah.
sudden it just, and then it worked one night, it wouldn't work another. And then I was kind of thought back of the objects I was shooting, and
yep. Uh,
when it wasn't working, it was when I had an object at zenith,
I won't keep you everybody, but I'll look that up at Joe and I'll send it to you.
I had
Thanks.
an issue
Okay.
with guiding it at the Meridian. Like I just started using
Right.
the AM5 and
Same
mount.
thing with that
And
too in that same
yeah,
version. Yep.
with Meridian, like I had to wait
Right.
like 15 minutes after it crossed the Meridian to even
Yep.
start guiding.
And
I,
then I had them check it a couple times and they said, well, we can't find anything here. Everything looks great because I figured I snagged a cable or something. I mean, it would calibrate and like the declination would be going off into
Yeah.
like it would
And
still
that was
track in right ascension, but not in declination.
that was
I was
part of
having
that problem. It would calibrate
right,
incorrectly, basically.
right. And then they were saying, well, call ZWO and maybe have them log in and I'm thinking, well, or I could drive to Texas and put some dynamite under it. I was really getting kind of frustrated with it, and then I realized when I shot an object that was just rising, like I shot that comet the other night, the Comet Lemon. I mean, it tracks absolutely perfectly. It was only when I started shooting it seeing it.
Yeah.
So
It
yeah, you
sounds like
guys
that problem.
could
Now
be.
they did push a new update out a couple
it was
weeks ago.
2.4, I think. It
Was
was
it
Yeah, they,
okay?
they
2.4.
I'll
went
have to look and see what
It
I
was, it
what
was, it
I'm
was
running.
2.4 in the ASI Air, and the firmware was 12.2.9, I think.
Okay. Yeah.
That was the problem I was having when I thought there was an issue with the camera, and I ended up trying to switch the cameras out in the middle of the night and dropped the camera
Yeah.
and broke it.
Yeah. It was getting really complicated, and I
Yeah.
was I was starting to say, geez, was this really the right thing to do? But then when I shot it's something that was, low on the horizon, it would track absolutely perfectly. And it was like Jack on Hyde. So it could be that. Anyway.
I don't know what version we're on now, though.
Okay.
I'm on 242 of the app.
Okay.
That's the latest one. But like I said, when I was around Meridian, it wouldn't guide near the Meridian at all. And ironically, the one thing I decided to do was the Meridian.
How
But it,
about
but
that?
but
Right.
but Scott, 2.4.2 is okay now, right?
Yeah. Well, like I said, I had to like when it was right at the Meridian, it would give an error and say that it couldn't track. So I had to wait like 15 minutes for it to like fully transition and
Right.
get far enough away. But then at that point, it was fine. Like
Yeah.
I didn't try Zenith though. So
Hmm.
because be careful, if it's coming to the Meridian and leaving it, I know there's that time value. You might have to expand it a little bit.
Right. Right.
So
Yeah. If it crosses the meridian and it started way before it's fine.
yeah.
Flips perfectly. Yeah. But
Can-
I have to give it to the ASI Air. It really is. I mean, it's very reliable.
It's been good. Yeah. It's that particular quirk drove me crazy because it was intermittent. But
Right.
when they rolled it back, it started working again. And then the new update seems to be it stayed fixed. That
Right.
problem with the Zenith stayed fixed.
Right. Yeah.
And I
When they
didn't
ins
notice anything
yeah,
else. I've been shooting with that, like that 30 hours I did was all
right.
with that new update and
Yeah.
you know, the M71 and some other stuff. And so far it's been, you know, fingers crossed, but so far it's been pretty stable, like
Yeah.
very stable.
Yeah, they upgraded it when they installed it, and that was late April. So it
No,
might have been even that, you know.
Yeah, because
Yeah.
this new update just was like weeks ago. I was
Right.
out there actually, and I had one. I have two scopes set up, so I got the one up and running, and I went to the other scope, and it was actually imaging when the update pushed through, and it actually
Right.
updated while it was imaging, and it's like, and I couldn't get to it because it was up,
Right.
and
Right.
it's sort of like, I guess it's still doing something. I don't know what
Right.
it's
No,
doing.
that's the story of my life. No.
It's like, I don't know.
I know.
I'm not sure what it's doing right now.
Yeah.
Hopefully it
I
doesn't
know.
swing
I
over
know.
and like jam the mount or something, but
Yeah.
it stayed there and then I rebooted it and you know, it seemed to be fine. I repointed it. But I was thinking now what's happening to the other scope in you know in the meantime, but that one I just left alone because it did give me an option to not do it now.
they do now. They
Yeah.
didn't. They
Yeah,
didn't.
now that like in this recent one, they didn't before,
Yeah.
just did it and would break stuff
I
sometimes.
always turn off Windows updates before I go out.
Yeah.
Well, no, this is, I mean, this
Good
is
luck
like,
with that, John.
Wait, I didn't think you used Windows. I thought you used Linux.
I
yeah,
know.
this is on the
I
iPhone.
do, but my imaging, yeah, nah.
Anyway,
I know it's real
Well-
late. Oh, I'm sorry. Okay, go ahead.
no, go ahead.
Okay, this is real quick. Not the normal. I tried doing this for the first time. It just because the moon was so pretty last night. I have
Ooh.
very little experience with DSLRs. This was I think can you see this?
Yeah.
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 Cool.
I haven't done anything with it. It doesn't look like it's quite in focus. Are there any tips or tricks on taking it was a full frame DSLR and it was a telephoto zoom. I think I had about 400 millimeters.
Don't overanalyze it.
Okay, sorry.
But I mean, a lot of it, I did a lot of DSLR landscape, just with especially when it comes to clouds and all that. Just don't analyze it. Just appreciate it and leave it as it.
All right, that's
Because
all
I
I
mean,
Great.
yeah, the focus is a little bit hard because of all the
What-
nature of it.
Yeah,
But
what do you try to focus on? I mean I was trying the moon, but the moon's covered by and that's what I kind of wanted to capture.
well,
It's focused on the moon.
I mean, if you could get stars or anything, you can focus on the star. I mean, just focus on anything that you can actually see. I mean, because they're all so far away, they're all essentially to infinity by that
Right.
point. So just
It looks
whatever
focused
you
to
can.
me.
Okay.
Yeah, I mean, I don't think it looks bad at all.
No, I never would have suspected it.
Yeah, and as I said, don't analyze. In this one, the moon's hidden enough, so even if it was out of focus, the moon doesn't look out of focus.
Yeah.
So
Well, it's the first time I tried anything like that. I just thought I'd throw it up there
Huh.
quick. That was it. I just
Hey,
getting
it's
nice
cool.
color.
That's always a nice effect when you get the moon behind clouds and stuff. It's a cool effect.
Yeah, I didn't do anything
You
with the
get
color
that, you
either.
get
This
those,
is
you know, rainbow, the rainbow arc around it and stuff like
Yeah.
that.
Artists love clouds.
curious that this orange, and this color because I didn't do anything to this. I didn't process this at all. Just right out of the camera.
Yeah, well, I mean,
How high was the moon? Like, was it just rising?
About 20, about maybe 30 degrees. It was in the southeast. I forget
Yeah,
what
so it's
time.
probably still has that yellow to it. So it's probably that yellow light
Hmm.
that added to the clouds.
well, you
I
also
bet
get
that's I
you also get a prism effect from the moisture
Hmm.
yeah.
in the clouds. Like if you look at the moon, if you look at like a full moon with high clouds or like high haze, you get
Yeah.
that circular kind of rainbow, and then you get another one far out. It's you know typical like kind of like sundogs. You almost get that sundog effect sometimes. It could be part of that.
I bet those cars are actually there. You know, our
Yeah.
eyes aren't good enough to see, color vision, but like that. But I bet it's actually there.
Yeah.
Hmm.
That's a cool shot.
Very nice.
Thanks. Yeah, I was happy with it. I had never done anything like that. I'm still learning how to use my DSLR. Thank you very much.
Some luck with the veil myself the other night. If I could show you that.
I'm gonna sign off.
Yeah, I have to. I'm
45 minutes over. It's a record, guys.
Yeah.
I'll stick around 5 more minutes. Let's see your image. I gotta go though soon.
Oh, here it is. It's only about 20 minutes. An hydrogen alpha and oxygen 3.
Don't see it yet.
Oh, really?
Yeah, do this. Should be share image and then pick full desktop.
Oh,
or
there
what-
it is.
Not, we don't see it quite yet. There it goes. There it goes.
Okay. Yeah, I was
Very
Great.
nice.
That's great.
oh,
oxygen 3 and hydrogen alpha.
Hmm.
So yeah, looks okay. I was amazed.
yeah.
Yeah. Is it a dual band filter?
Yeah, one. It's I'm not sure of the brand, but it was a hydrogen alpha and oxygen 3 narrow band,
Yeah,
7 nanometers or something.
that's so
Very
cool.
nice.
That's great.
Yeah, I was
Very, very
pleased.
nice.
So yeah,
Very good.
Very nice.
Right. Hey. Well, until next time.
thanks, Gary.